Every grand enigma commences with a location. Ours originates in Sagittarius, a cosmic confluence, a nexus where the improbable intersects. This is precisely where our investigators have pinpointed the genesis of 3 Atlas, the very same sector of the heavens from which, many decades prior, the wow signal pierced the profound stillness. A mere happenstance? Absolutely not. It is far too precise, far too deliberate. It is conceivable that some entity or consciousness is already reaching out to us. Stay tuned, for this evening we shall endeavor to decipher why the trajectory of Atlas appears anything but random, and why 3 Atlas may have been attentively observing, patiently awaiting in silence all along. Should this puzzle captivate you as it has me, be sure to bestow a like and subscribe to ensure you remain abreast of every development as this narrative unfolds in real time. Drop a comment detailing your current location, the local time, and whether you firmly believe we are being furnished with the complete account of these astonishing revelations. And if your desire is to contribute to the expansion of this community, please disseminate this video across X, Facebook, Reddit, or even within your personal group discussions. It is your support that empowers us to persist in pursuing stories of this magnitude. Therefore, our profound gratitude for your unwavering backing. Part 1. The Startling Genesis. As the astronomers meticulously traced the orbital path of 3I Atlas backward through the eons, factoring in its trajectory across countless millennia of galactic locomotion, their expectation was to discover a parent star system, perhaps a stellar nursery or a fragmented planetary disk that had launched this wanderer into the vast expanse. Instead, they encountered a finding that brought their work to an abrupt halt. The object's course, when rewound as if viewing a cosmic motion picture in reverse, pointed directly back towards Sagittarius, the self-same constellation, the very same celestial expanse that furnished us with the most compelling evidence to date for intelligent extraterrestrial life. The 1977 WOW signal, not in some vaguely similar vicinity, but the exact region. The archer's bow was aimed directly at our planet. This is not the typical progression of scientific inquiry. Fortuitous occurrences do transpire without question, but occurrences of such exactitude, so profoundly laden with implication, compel one to ponder whether they are witnessing mere random chance or a deliberate design intended for recognition. 3 distinct factors are converging here in a manner that suggests not serendipity, but rather orchestrated design. Firstly, an interstellar object, an authenticated visitor from beyond our solar system, arrives from Sagittarius, having undertaken a journey that may have spanned millions of years. Secondly, the most robust candidate for a SETI signal ever documented, a 72-second burst of radio waves so intensely focused and narrow in bandwidth that the astronomer Jerry Eman famously scrawled "WOW" on the printout, originated from Sagittarius in August of 1977. Thirdly, Earth itself has been emitting radio signals into the cosmos for close to a century, and some of those transmissions have already traversed the vast distances to reach stars within Sagittarius, propagating outwards at the speed of light, effectively announcing our existence to any potential listeners. 3I Atlas was first identified in the year 2020, its classification as interstellar stemming from its hyperbolic orbital path. This type of trajectory unequivocally indicates that the object is not gravitationally tethered to our Sun. It originated elsewhere, passed through our solar system, and will eventually depart, resuming its journey into the interstellar void. Unlike the majority of comets, which adhere to elliptical orbits that necessitate their periodic return, interstellar objects are singular visitors. They appear, they depart, and if they are not observed during their brief transit, the opportunity to study them is lost forever. This renders every detection of an interstellar object profoundly valuable, and every detail pertaining to its origins critical for understanding its source and the potential insights it might offer regarding other stellar systems. The WOW signal remains an enigma nearly 50 years after its initial detection. On the 15th of August, 1977, at precisely 23 minutes past 11 in the evening, the Big Ear radio telescope situated at Ohio State University registered a potent, narrow-band signal at a frequency of 1,420 megahertz, the hydrogen line. This frequency aligns precisely with the wavelength that SETI researchers theorized extraterrestrial civilizations might employ, as it represents a fundamental wavelength that any technologically advanced species studying the universe would undoubtedly discover. The signal was so unmistakably artificial, so distinct from the ambient cosmic noise, that it could not be attributed to instrumental malfunction or atmospheric interference. However, it never recurred. Subsequent observational efforts targeting the same celestial sector yielded no results. No further detection has ever replicated its distinctive characteristics. For nearly 5 decades, it has remained suspended in scientific ambiguity, too compelling to dismiss, yet too elusive to definitively confirm. Meanwhile, Earth's radio emissions have been continuously expanding since the advent of broadcast technology. Every television program, every radar pulse, every radio transmission inevitably leaks into space, propagating outwards in a sphere that now spans approximately 200 light-years in diameter. This expanding sphere encompasses thousands of stars, including a significant number within Sagittarius. If technologically advanced civilizations exist in proximity to any of those stars, they have been receiving our broadcasts for many decades. They are aware of our presence. They comprehend our technological capabilities. Theoretically, they might have been observing episodes of I Love Lucy since the 1950s, analyzing our radar signatures, monitoring our military communications, and meticulously constructing a profile of our civilization based on the electromagnetic imprint we have so carelessly dispersed across the galaxy. The convergence of these events is precisely what demands our attention. An object materializes from the same celestial direction as our most significant SETI finding. That particular direction happens to be one towards which we have been broadcasting for an entire century. The timeline creates a feedback loop. Signals dispatched outwards, signals received inwards, an object arriving. This scenario appears less like 3 disconnected coincidences and more akin to 3 distinct acts within the same unfolding drama. A cosmic exchange playing out across decades and light years, with Earth serving as both the sender and the recipient, both the civilization extending an overture and the civilization being addressed. If Sagittarius holds a unique significance, if it is more than merely another constellation amongst the 88 arbitrary star patterns conceived by humanity, then a deeper understanding of its nature is imperative. One particular hypothesis evokes a blend of chilling apprehension and profound excitement. What if Sagittarius is not simply a directional point, but rather a central hub? A galactic crossroads where transmissions converge and probes conduct surveillance. A place where civilizations separated by unimaginable gulfs of distance have established a form of interconnected network, with nodes strategically positioned to observe the emergence and self-declaration of nascent technological species. What if our transmissions have been directed towards a cosmic neighborhood that was already inhabited, already equipped with infrastructure that currently eludes our comprehension, already observing us with a patience measured not in years, but in geological epochs? This reframes 3 Atlas from a mere astronomical curiosity into something of considerably greater importance. Not simply a visitor, but potentially an emissary, an exploratory device, a tangible artifact of contact arriving at precisely the juncture and in the location where it would most clearly resonate with our own endeavors in cosmic communication. The researchers who meticulously retraced this object's orbital path harbored no expectation of such extraordinary findings. They were engaged in standard analytical procedures, the kind of computational work that is a daily occurrence in the field of astronomy. This involves taking an object's current trajectory and integrating it through the gravitational field of the galaxy, meticulously accounting for stellar interactions and tidal forces. The objective is to ascertain its point of origin. In most instances, this process yields results that align with established theoretical frameworks. Comets trace their origins back to the Oort cloud, asteroids to the main belt or Trojan populations, and interstellar objects to stellar flybys that propelled them away from their parent systems. However, 3 Atlas defied these conventional expectations. Its trajectory, when traced backward, led to Sagittarius and then continued further, extending through millions of years without revealing a definitive origin point, as if the object had been in perpetual motion, as if its path had been deliberately set rather than naturally determined. This presents a fundamental interpretive challenge. Either the object is of such immense age that its origins have been obscured by millions of years of galactic orbital mechanics, rendering it effectively untraceable, or there is something about its trajectory that deviates from natural models. The former explanation is unsettling, as it implies we are examining debris that could be billions of years old, a relic from stellar systems that may no longer even exist. The latter explanation is even more disquieting, as it opens the possibility of artificial origins, suggesting that 3 Atlas's path was meticulously calculated rather than occurring by chance, designed to traverse our solar system at this specific moment in human history, when we possess just enough technological sophistication to detect it and sufficient curiosity to pose these profound questions. If the trajectory was indeed engineered, if some intelligence set this object on its course millennia or even millions of years ago, precisely timing its arrival for the present, then the connection to Sagittarius transforms from a mere coincidence into a clear signature. It conveys a message. We heard you. We are responding. We originate from the very location you have been signaling towards, the very location that first signaled you. The wow signal thus evolves from an isolated enigma into the inaugural chapter of an extended dialogue. 3i Atlas becomes the second part, leaving us to contemplate the nature of the third. Whether it is already en route, whether we will recognize its arrival, and whether we are truly prepared for the implications of contact when it manifests not as a grand declaration, but as a series of subtle alignments that require decades to discern and comprehend. The profound shock lies not merely in the fact that an interstellar object originated from Sagittarius. The true shock is its arrival from Sagittarius at precisely the temporal juncture when our technological prowess allows us to trace orbits backward, exactly when we are grappling with the question of our solitude, and precisely when our own signals have penetrated far enough into that region to plausibly elicit a response. The timing, the direction, the convergence of outgoing and incoming transmissions, all of it strongly suggests that we may not be actively discovering contact so much as finally recognizing it. Perhaps, after unfolding around us for years without our awareness, 3 Atlas represents not the commencement of something new, but rather the continuation of a conversation, a dialogue we initiated decades ago, unaware that the universe was attentively listening. Part 2. Orbital Forensics. The act of tracing an object's trajectory backward through time is akin to performing detective work on a cosmic scale. Astronomers begin with the object's current position and velocity, data meticulously gathered from multiple observations as it traverses the night sky. This information is then fed into sophisticated simulations that model the gravitational influences exerted by every significant celestial body within the galaxy: the Sun, the planets, neighboring stars, and even the galactic disk itself, taking into account the cumulative tidal effects of dark matter distributed throughout the Milky Way. The simulation then runs in reverse, calculating the object's prior positions over the past year, century, and even millennia, meticulously factoring in all gravitational perturbations that would have impacted its path. If the object's origin can be attributed to a stellar flyby or ejection from a planetary system, this backward integration should, in theory, eventually lead it in close proximity to a star that could plausibly be identified as its parent. The Gaia Space Telescope has revolutionized this field of research. The Gaia Data Release 3 contains incredibly precise positional data, distances, and velocities for over 1 billion stars. For the very first time in human history, we possess the capability to reconstruct the three-dimensional motion of our stellar neighborhood across vast stretches of time. We can now ascertain which stars were in our vicinity in the past, which ones will approach us in the future, and which ones have crossed paths with objects of particular interest. When Oumuamua, the second confirmed interstellar visitor, was discovered in 2019, researchers utilized Gaia data to chart its origin. They determined that it hailed from the general vicinity of a young stellar association, a collection of stars that were formed together and continued to drift collectively through the galaxy. While the correlation was not perfectly exact, it was considered plausible. Oumuamua was identified as a pristine comet, ejected from a planetary system during its formation and sent on an interstellar journey until it coincidentally passed through our solar system. 3 Atlas, however, offers no such straightforward explanation. Researchers meticulously examined dozens of potential stellar encounters, initiating the backward integration process and searching for close proximity events with stars that might have hosted the object at some point. They found nothing. No star came sufficiently close to the reconstructed path of 3 Atlas to be considered a plausible origin point. Some encounters registered as marginally significant, but were subsequently dismissed due to discrepancies in velocity. The object would have required an implausible acceleration to escape from those particular systems. Others were discounted due to timing issues. The encountered events occurred too recently to account for the object's apparent age and trajectory. The further the backward integration progressed, the more distorted the orbital path became, influenced by galactic tides and cumulative perturbations from distant celestial masses. Ultimately, the margin of error expands to such a degree that it becomes impossible to reliably determine the object's precise location millions of years ago. This situation is unprecedented for an interstellar object. We anticipate that these visitors should, at least in principle, be traceable because they undeniably originated from somewhere. Stars constantly eject comets and asteroids during the complex processes of planetary system formation and evolution. Close encounters between stars can scatter these objects, propelling some into interstellar space while retaining others in bound orbits. Over billions of years, the galaxy should be replete with these celestial wanderers, traversing the spaces between stellar systems and occasionally intersecting our own by chance. The object designated 2I Borisov fits this model perfectly. The first confirmed interstellar object, Oumuamua, discovered in 2017, proved more challenging to trace, yet its characteristics were still considered plausibly natural, although its unusual attributes did spark ongoing discussions regarding a potential artificial origin. 3 Atlas, however, disrupts this established pattern. Its orbital path does not correlate with any discernible natural source. This leads to 2 competing explanations, neither of which is entirely comfortable. The first posits that the object is exceptionally ancient, possessing an age so profound that reconstructing its history is beyond our current capabilities. If it has been traversing space for billions of years, if it was ejected from a stellar system that has since migrated significantly from its original position due to galactic orbital mechanics, then the trail has effectively grown too cold to follow. The galaxy undergoes rotation. Stars move in intricate patterns, influenced by spiral density waves and gravitational interactions. Over extended periods, any discernible link between an object and its point of origin dissolves into uncertainty. In such a scenario, we would be examining fossilized debris, a relic from an era when the galaxy's structure was fundamentally different, when the stars within Sagittarius occupied vastly different positions, and when the very concept of Sagittarius as a human-defined constellation would have been meaningless, as Earth had not yet come into existence. The second explanation proposes that the trajectory was not natural in the first place. If an intelligence, either singular or collective, deliberately placed 3 Atlas on its current course, meticulously calculating its path to intersect our solar system, then orbital backtracing would fail to identify a natural ejection event because no such event occurred. The object's trajectory would have been dictated by engineering principles, not by the forces of gravity alone. This scenario does not necessitate faster-than-light travel or technology that defies known physical laws. It simply requires immense patience and extraordinary precision. The object would have been launched millions of years ago. Its trajectory would have been carefully aimed, accounting for galactic motion and stellar positions. It would then have coasted along a ballistic path, requiring no further propulsion and arriving precisely when and where intended. From our observational perspective, it would appear as an interstellar visitor following natural orbital mechanics. However, underlying this apparent natural motion would be a chosen, rather than random, set of parameters. The concept of deliberate trajectory insertion deeply unsettles most astronomers, as it is inherently unfalsifiable without the acquisition of additional evidence. One cannot definitively prove an orbit was engineered rather than natural, unless the object exhibits behavior that natural objects are incapable of. This could include non-gravitational acceleration exceeding that explained by cometary outgassing, trajectory adjustments indicating active guidance signals, or emissions that unequivocally demonstrate technological origin. 3i Atlas has not, thus far, conclusively demonstrated any of these characteristics, although, as previously discussed, there have been assertions of unusual behavior. What it has done is resist standard orbital reconstruction, pointing towards a general region rather than a specific origin. It has arrived from a direction imbued with profound significance for human SETI endeavors, timing its appearance for an era when we are only marginally equipped to conduct a thorough study of it. The forensic evidence is, by design, inconclusive. If one were intent on sending a probe to another civilization, a deliberate choice might be made to select a trajectory that, at first glance, appears natural, one that would not immediately signal artificiality to casual observation. It might be disguised as a comet or an asteroid, an object that would not trigger immediate alarm or intensive scrutiny. It would be allowed to drift for millions of years, exhibiting a patience that transcends human comprehension, because while civilizations may rise and fall, the fundamental laws of physics remain eternal. Upon its arrival, it would simply appear as another piece of space debris, intriguing to astronomers, but not immediately identifiable as a deliberate act of contact. Only when close examination is undertaken, when the right questions are posed, and when patterns begin to emerge, does the true nature of the visit become apparent. Alternatively, we might be overthinking the situation. The cosmos is teeming with ancient debris. The galaxy contains 400 billion stars and trillions of smaller objects adrift between them. Some of these objects will possess untraceable origins simply because they are incredibly ancient, having traveled for such vast distances and for such immense durations that their history can no longer be reconstructed with the data currently available. The fact that 3 Atlas points in the direction of Sagittarius could be entirely coincidental. The fact that it resists orbital reconstruction might simply indicate that it is older and its trajectory more disturbed than that of 2i Borisov. To ascribe intention to what could be random motion is an exercise in pattern recognition, not rigorous scientific inquiry. Yet the pattern persists, seemingly begging for notice and demanding interpretation, even if such interpretation necessitates accepting that some coincidences, no matter how loaded they feel, are indeed just coincidences. This fundamental dilemma lies at the very heart of this investigation, acting like a black hole that distorts everything around it. Either Three-Eye Atlas is an object of such immense antiquity that its origins are beyond our capacity to reconstruct, a celestial wanderer so ancient that its genesis story has been irrevocably erased by time, or it is something entirely different, something deliberately placed rather than naturally ejected, something guided rather than randomly propelled. The orbital forensics alone cannot definitively differentiate between these two possibilities, as both scenarios produce the same observable signature, an object lacking a clearly identifiable parent star with no discernible natural ejection event, whose trajectory traces backward to a general celestial region rather than a specific point of origin. What will ultimately resolve this ambiguity? What will allow us to choose definitively between a random occurrence and a designed event will be all the subsequent information we gather about this object, everything beyond the mere analysis of its trajectory. The orbit directs our attention to Sagittarius. Now, the crucial task is to comprehend what Sagittarius itself might represent. Part 3. The Sagittarius Neighborhood. Sagittarius commands our view of the galactic center. When we direct our gaze towards the constellation known as the Archer, we are looking through the most densely populated star field within our galaxy. We are peering towards the supermassive black hole that serves as the anchor for the Milky Way's rotation, advancing towards the galactic bulge where stellar populations are densely clustered in configurations that are simply not possible within our comparatively quiescent spiral arms. This region is the galaxy's bustling downtown, its metropolitan core, where gravitational forces are most potent and matter coalesces with extraordinary density. Regions of active star formation blaze with intense ultraviolet radiation emanating from newly formed stellar clusters. Ancient red giants, billions of years old, traverse orbits that have circumnavigated the galactic center hundreds of times. This area is all-encompassing, a cradle for new life and a final resting place for the old, a construction site and a ruin. The most vibrant and the most ancient stellar populations coexist within a space so densely packed that from the perspective of a planet situated within this region, the night sky might present thousands of stars brighter than our own brightest star. This inherent density makes Sagittarius a natural convergence point, a crossroads where trajectories originating from disparate parts of the galaxy might plausibly intersect. If one were to establish a monitoring station or a relay node in a location offering maximum potential for interaction with passing civilizations, where the probability of eventually encountering another technologically advanced species would be at its highest, the galactic center region would undoubtedly be the most logical choice. More celestial bodies imply more planetary systems, thus increasing the probability of life and intelligence emerging. This region has been a constant cradle of star formation throughout the galaxy's existence, meaning any civilizations that developed there had a significant temporal advantage, measured in billions of years. While humanity's ancestors were still single-celled life forms, just beginning to harness photosynthesis, civilizations within Sagittarius could have already been ancient, potentially having expanded across the region and established infrastructure that we are only now developing the capacity to detect. The statistical likelihood of 3 of the Oumuamua objects pointing towards Sagittarius by pure chance depends entirely on how the question is phrased. The sky is divided into 88 constellations of varying magnitudes. Sagittarius is a large expanse, occupying a substantial portion of the celestial sphere. Therefore, any given direction has perhaps a 5 or 10% chance of falling within its boundaries, depending on how those borders are defined. This probability doesn't appear particularly improbable. However, When the wow signal is introduced, and we specify not just any constellation, but the one that produced the most significant SETI candidate ever detected, the odds become considerably tighter. Furthermore, when Earth's broadcast history is added, specifying the constellation we have inadvertently been broadcasting towards for decades, the coincidence becomes increasingly difficult to disregard. You are not asking about the chances of pointing towards any constellation. You are asking about the odds of all these elements converging on the same constellation. This is a far more constrained inquiry. Sagittarius has featured in human mythology for millennia, depicted as the archer, a centaur drawing its bow, aiming towards the nearby constellation of Scorpius. Ancient cultures observed this asterism and wove narratives around it. They envisioned a hunter, a warrior, a guardian situated at the frontier between the known world and the cosmic unknown. They could not have comprehended that they were gazing towards the galactic center. They were unaware of the supermassive black hole lurking there, nor the dense congregations of stars, nor the star-forming regions blazing with energies that would one day be visible through telescopes humans had yet to conceive. Yet, they sensed something, embedding significance into that celestial direction, making it a focal point for stories concerning power, peril, and the mysteries beyond. Contemporary science wisely advises caution against overinterpreting coincidences, and this prudence is beneficial. We are predisposed to perceive patterns. Our minds connect disparate points even when no actual link exists, because the consequences of false positives were less detrimental to our ancestors than false negatives. It was safer to perceive predators in every shadow than to overlook a genuine threat. This cognitive bias means we will find significance in Sagittarius, even if it is merely another direction among an infinite array of possibilities. Even if the wow signal was a natural radio burst from a magnetar or some other astrophysical source we have yet to identify. Even if the Oumuamua objects arrived in that region purely by chance, scientists consistently push back against this inclination, demanding concrete evidence before accepting extraordinary assertions and requiring that perceived patterns withstand rigorous statistical analysis before being elevated to the status of discoveries. Nevertheless, a conspiratorial framing possesses its own logic. An accumulation of too many coincidences begins to resemble a signal rather than mere happenstance. At what juncture does astronomical improbability transform into something likely, not random? Where lies the dividing line between healthy skepticism and deliberate ignorance of patterns warranting investigation? If the Oumuamua objects had originated from any other direction, we likely would not be having this discussion. Had the WOW signal emanated from Orion or Andromeda instead of Sagittarius, the origin of the interstellar object would have been just another data point. It is this convergence that generates urgency, that elevates orbital forensics from an academic exercise to a potential first contact scenario. And this convergence continues to intensify with each added layer. The galactic disk rotates, and Sagittarius lies in the direction of this rotation, the direction in which our solar system is progressing as we orbit the galactic center. This positioning makes it a natural convergence point for objects approaching from that direction and our own movement through space. If one intended to intercept our solar system, launching from the galactic center region and orchestrating the arrival during our passage, would present geometric advantages. The relative velocities align favorably. The trajectories naturally fall into place. An object traveling from Sagittarius towards our current location would not require intricate maneuvering. It would only necessitate precise timing, a launch calculated to place it in our path at the opportune moment. This does not constitute proof of design, but it addresses one potential objection. Why Sagittarius specifically? Because that is the direction from which interception is most straightforward. Astronomers examining the Oumuamua objects continue to conduct simulations, refine their calculations, and check for close encounters with stars catalogued by Gaia. Some are seeking their parent systems. Others are exploring the hypothesis of ancient trajectories, attempting to model the galactic environment as it existed millions or billions of years ago when the object might have been ejected. Still others are privately considering the artificial hypothesis, refraining from publishing their findings due to the career implications without extraordinary evidence, but performing private calculations to ascertain what a deliberately inserted trajectory would resemble and whether the data supports it. The scientific community is divided, cautious, acutely aware that this could represent the most profound discovery in human history or a spectacular waste of resources on a mere rock. Sagittarius rests at the heart of this uncertainty, a direction that signifies nothing and yet might signify everything. The constellation itself is an arbitrary human construct, a pattern drawn by connecting stars that possess no intrinsic physical relationship but happen to align along the same line of sight from our vantage point. However, the galactic center is real. The dense stellar populations are real. The fact that our most compelling SETI signal originated from that locale is real. And now an interstellar object has arrived from that same direction. It is untraceable, resistant to standard analysis, and its arrival is timed for an era when humanity has just attained sufficient sophistication to discern the pattern and possesses enough curiosity to ponder whether patterns sometimes reflect their apparent meaning. If Sagittarius serves as a nexus, a waypoint, a monitored zone where nascent civilizations are observed and evaluated, we are on the verge of discovery. And this revelation might not be dramatic. It might manifest as a gradual dawning realization that the coincidences are not coincidental, that we are being noticed, that the Archer's arrow has been in flight for millions of years, and we are only now perceiving its arrival. Part 4, 1977. A Peculiar Alignment. August. The month of August in 1977 was remarkable for humanity's engagement with the cosmos, though its significance was not fully grasped at the time. Two occurrences, separated by mere days, would later appear less like coincidence and more like symmetry. Two notes in a grander composition we are still striving to decipher. On August 20th, NASA dispatched Voyager 2, a robotic probe engineered to investigate the outer planets before continuing its journey into interstellar space. It carried a golden record, encoded with images, music, and greetings from Earth in 55 languages. The spacecraft's eventual trajectory would lead it towards the constellation Sagittarius and Pavo, descending below the solar system's plane and heading towards the galactic south, conveying our message outwards at 35,000 miles per hour, a speed that seems swift by human standards, but is exceedingly slow on a cosmic scale. 5 days earlier, on August 15th, the Big Ear radio telescope registered the WOW signal. The timing creates a symmetrical framing that is impossible to overlook once recognized. Earth dispatches a physical probe aimed towards Sagittarius, and almost concurrently, we receive what remains the strongest candidate radio signal for extraterrestrial intelligence, originating from Sagittarius. A message outward, a message inward, a launch, and a detection. This symmetry would be poetic were it not so disquieting. Were it not to suggest that perhaps, just perhaps, these events were not independent. Perhaps an observer, something or someone was watching, noted our preparations to send Voyager, and responded promptly with a signal timed to arrive just before the launch, conveying, "We observe you. We are present. We are located in the direction you are sending your probe." This interpretation necessitates extraordinary timing. However, timing is precisely what technology provides. If a monitoring system existed in Sagittarius, and if it had been observing Earth for decades or even centuries, it would have witnessed our technological advancements. Radio transmissions commenced in the 1920s, television broadcasting became widespread in the 1950s, and increasingly powerful radar and deliberate SETI transmissions emerged in the 1960s and 70s. Such a system would have calculated the duration for its own signals to reach Earth at the speed of light. If it had chosen to acknowledge our emergence as a species capable of radio communication, it would have transmitted its signal years or decades prior, carefully timing its arrival for maximum impact, for a moment when we would be actively contemplating interstellar communication, when we would be most receptive to noticing and investigating rather than dismissing it. Voyager 2's golden record represents humanity's most deliberate endeavor in cosmic communication prior to that period. The record contains 116 images depicting Earth's diversity, alongside mathematical and physical principles, human anatomy, fauna, flora, architectural achievements, and technological advancements. It includes 90 minutes of music from various global cultures. It also features greetings in 55 languages, supplemented by whale songs, acknowledging Earth's other intelligent species, even if they lack the capacity for spacecraft construction. The record is analog, playable with the included cartridge and stylus, designed to endure for billions of years in the interstellar environment. We embedded instructions for its playback on the record's cover, utilizing universal physical constants to define timing and dimensions, thereby enabling any technologically advanced species to decode it, irrespective of their familiarity with human culture. The assumption was that Voyager would drift for millennia or millions of years before encountering any other entities. The golden record was akin to a message in a bottle cast into an ocean so vast that its recovery seemed practically impossible. We undertook this endeavor nonetheless, not with the expectation of a response, but because the act of crafting the message held inherent value for us. It compelled us to contemplate what we would convey if we could communicate with the cosmos, and what we would choose to represent humanity when limited to a few megabytes of data storage and a single 12-inch disk. The selections involved political, philosophical, and artistic considerations. What music best defines us? Which images? Which languages? The record serves as a time capsule of 1977 human consciousness, as much as it is a message to extraterrestrials. Fast forward to 2025. Voyager 2 is now approximately 150 astronomical units from the Sun. It remains functional, although its power supply is deteriorating. It continues to transmit data concerning the interstellar medium, the region of space between stars that no human-made object had previously entered. It travels at approximately 3.1 astronomical units per year, which translates to roughly 10,000 miles per hour relative to the Sun. At this velocity, it would take approximately 40,000 years to traverse 1 light year. The nearest stars are over 4 light years distant. Voyager will not approach another stellar system for hundreds of thousands of years. By that time, humanity may no longer exist. The probe will outlast us, carrying our message into a future where Earth is a distant memory. However, here is the crucial point. Voyager is heading towards Sagittarius and Pavo, and the Oumuamua objects originated from Sagittarius. One object departing, one arriving, both connected to the same celestial region. The objects will not intersect. Clearly, the Oumuamua objects have already passed through our solar system and are heading back outwards. Voyager follows a completely different trajectory. Yet, symbolically, metaphorically, their counterparts, our outgoing message and their incoming probe, assuming that is what it is, their paths cross in conceptual space, even if they never physically intersect. We are sending an artifact of our civilization into the cosmos, and the cosmos may have sent one back. A reply not in radio waves but in physical form, an object that rewards close examination with implications that grow increasingly peculiar the more they are scrutinized. The 1977 alignment is considered by some researchers to mark year zero of cosmic communication. Prior to that year, we were transmitting radio and television signals, but passively, incidentally, not with the deliberate intent of communicating with any entities beyond Earth. Voyager altered this paradigm. It made our intention explicit. We were reaching out, offering a greeting, hoping that someone might be there to receive it. And almost simultaneously, we received the wow signal, a reciprocal greeting, potentially, if that is indeed what it was. Decades later, the Oumuamua objects arrive from the same direction, completing a trilogy. Signal outward, signal inward, object inward. Each component can be individually explained as natural or coincidental. Collectively, they form a pattern that is more difficult to dismiss. What transpires when the outbound Voyager and the inbound Oumuamua objects traverse paths across vast cosmic distances? They will not physically meet, but the civilizations or intelligences associated with them might. If the Oumuamua objects represent a probe, it transmitted information back to its origin, possibly years or centuries ago, depending on the nature of their communication. That information includes data about our solar system, our planets, and, if it possessed the capability to detect electromagnetic emissions, our technology. The civilization receiving that data would be aware of our existence. They would ascertain our technological level, approximately that of the 1970s, based on Voyager's launch and the Golden Record. They would possess a profile of us, our capabilities, our intentions, and our willingness to reach out. And they would then face the decision of how to utilize that information, respond openly, continue silent monitoring, dispatch additional probes, or disregard us as too primitive for engagement at this time. The peculiar alignment of 1977 suggests that we may already be engaged in a dialogue without fully comprehending it. The wow signal was not a random occurrence, it was a response. Voyager was not merely humanity conversing with itself, performing an empty gesture of hope. It was the initial move in an exchange that is still unfolding and will continue to do so across timescales that humans find challenging to conceptualize. The Oumuamua objects represent the subsequent move, a physical artifact following the radio signal. It is tangible proof that someone or something exists beyond our world and is sufficiently interested to dispatch hardware, not merely electromagnetic whispers. And we are left contemplating what the next move will be, whether we are prepared for it, and whether first contact is an event that occurs suddenly or gradually over decades and centuries in fragments that only become coherent when viewed in their entirety. Part 5. The initial dilemma. We find ourselves suspended between two potential explanations for the Oumuamua objects, and the choice between them shapes all subsequent considerations. On one hand, there is the naturalistic explanation. Interstellar objects are commonplace, with perhaps thousands passing through our solar system annually, too small or faint to be detected. They are fragments from planetary formation processes, dispersed throughout the galaxy by gravitational interactions. The Oumuamua objects are simply among these, notable only because we manage to observe them, because our detection capabilities are improving, but ultimately just inanimate matter. Their trajectory towards Sagittarius is coincidental. Their apparent untraceability is attributed to their antiquity or to the limitations of our current models. The connection to the wow signal is a product of pattern recognition, humans finding significance where only randomness exists. This explanation is conservative, aligns with established physics, and requires no new assumptions about alien civilizations or interstellar probes. It is the explanation most scientists default to because extraordinary claims necessitate extraordinary evidence, and we currently lack that evidence. On the other hand, there is the engineered explanation. The Oumuamua objects are interstellar probes deliberately sent to our solar system, possibly part of a larger network of monitoring devices strategically placed throughout the galaxy. Their trajectories were calculated, not random. Their timing is intentional. Their linkage to Sagittarius and the WOW signal are integral components of a communication strategy we are only beginning to recognize. The probe is camouflaged as a natural object because that would be the logical approach if one wished to observe without inciting panic, if one desired to allow the target civilization to discover them gradually, rather than announcing their presence in a dramatic fashion. This explanation necessitates accepting the existence of another technological civilization, that interstellar travel, or at least interstellar probe capabilities, have been employed to monitor us, and that this specific moment was chosen for a subtle contact, subtle enough that we must actively work to perceive it. The concept of the probe hypothesis is not novel. It originated in 1960 when physicist Ronald Bracewell proposed that advanced civilizations might utilize autonomous probes rather than radio signals for interstellar communication. Radio waves travel at the speed of light but diminish with distance, demanding immense power for interstellar ranges. Probes, while slower, can carry more information, adapt to local conditions, and observe and wait for civilizations to develop technology before revealing themselves. A galaxy-spanning network of Bracewell probes could effectively establish an interstellar internet. Nodes strategically positioned throughout the galaxy would monitor star systems, awaiting signs of emergent intelligence. Upon detecting radio signals or other technosignatures, a probe might activate, commence signaling, and perhaps even approach the system to study the newly emerged civilization more closely. What would an alien probe realistically resemble? Likely not a sleek spacecraft with overt technological features, as that would be inefficient and draw undue attention. More plausibly, it would be disguised as something natural: a comet, an asteroid, a piece of space debris indistinguishable from the countless natural objects drifting through any stellar system. This disguise serves several purposes. It prevents triggering defensive reactions from the target civilization. It allows the probe to operate undetected for centuries or millennia while the civilization matures. It ensures that when contact does occur, it happens on the probe's terms, when the civilization has reached a sufficient level of technological sophistication to recognize the probe for what it is, rather than misidentifying it as mere space rock. SETI researchers have long contended that advanced civilizations would likely prioritize stealth over ostentation. Transmitting powerful radio signals requires substantial energy and broadcasts one's presence to any potential adversaries within listening range. Dispatching probes is a quieter approach. Probes can conduct passive observation, gathering data without revealing themselves until they choose to do so. This aligns with the dark forest hypothesis, the notion that the galaxy might be populated by civilizations deliberately remaining silent because attracting attention is perilous. If this hypothesis holds true, then first contact would not manifest as a dramatic arrival of obvious spacecraft. It would be subtle, gradual, something easily overlooked if one is not paying close attention. It would closely resemble what we are currently observing with the Oumuamua objects, an object that appears natural at first glance but reveals strangeness upon closer inspection, with connections to historical signals and patterns suggesting intention rather than randomness. The concept of relay nodes expands on this idea. Instead of individual probes operating in isolation, envision a network where each probe communicates with others, forming a web of information exchange across interstellar distances. These probes would be positioned every few hundred light-years throughout the galaxy, each observing its immediate surroundings, each transmitting updates to the collective when significant occurrences are detected. Celestial bodies forming, planetary masses aggregating, life spontaneously appearing, intelligent societies advancing their technical capabilities. The network would not necessitate faster-than-light travel. Electromagnetic waves propagating at the speed of light between interconnected points would suffice for any civilization or supra-civilization with the patience to contemplate epochs spanning millions of years. Our own planet would be merely one among countless systems under surveillance. Our progress meticulously documented, our transmissions duly recorded, our evolution into a technologically advanced species noted and catalogued. The Fermi paradox poses the question, given the galaxy's vast age and the apparent prevalence of life, where is everyone? Why have clear indications of extraterrestrial societies eluded us? One proposed solution suggests we have indeed encountered evidence, but failed to recognize it. We may have mistaken interstellar craft for celestial bodies, radio signals for natural cosmic emissions, coincidental occurrences for mere chance. Our expectation of contact was one of overt and unambiguous interaction, with alien entities announcing their presence dramatically, akin to cinematic portrayals. However, what if contact is already underway, has been for decades, and we are only now beginning to assemble the disparate fragments of evidence? What if Oumuamua, the wow signal, and numerous other anomalies we have dismissed or rationalized away are all interconnected facets of the same phenomenon, components of a network we are finally developing the sophistication to discern? This juncture transforms the dilemma from a purely scientific quandary into an existential one. Should Oumuamua be interpreted as a natural occurrence, we remain essentially solitary within the universe, or at least within our immediate cosmic vicinity, pursuing signals that may never materialize, constructing narratives of cosmic solitude. Conversely, if it is an artifact, our entire understanding is altered. We are under observation, integrated into a larger framework beyond our construction or dominion. Our transmissions did not vanish into the void. They were received, scrutinized, and answered. The wow signal was not an enigma awaiting astrophysical explanation, but rather an overture, a test of our attentiveness and capacity for response. And Oumuamua represents the follow-up, a tangible object whose further investigation yields increasingly profound implications. The conventional stance advocates for maintained skepticism until irrefutable proof emerges. Most researchers adopt this position due to its methodological rigor. Established understanding is not overturned based on ambiguous data and compelling patterns. One awaits definitive evidence, clear transmissions, undeniable artifacts, and reproducible phenomena devoid of natural explanations. The challenge lies in the possibility that contact is intentionally subtle. If the originators of Oumuamua intended for its discovery to be a gradual process rather than an immediate revelation, we may never obtain the definitive proof we seek. Instead, we may encounter precisely what we are experiencing now, a series of unexplained phenomena accumulating into a discernible pattern, detectable by those who are observant, yet dismissible by those who favor conventional interpretations. The more radical approach is to tentatively accept the probe hypothesis and explore its ramifications. This does not imply belief without substantiation, but rather treating the hypothesis as worthy of serious investigation, dedicating resources to its examination, and actively seeking additional data that could either validate or invalidate it. If Oumuamua is indeed a probe, it might exhibit behaviors inconsistent with natural objects, such as trajectory adjustments, emissions undetectable at our observed frequencies or times, or reactions to our own observations or transmissions. Re-examining existing data with the probe hypothesis in mind could reveal patterns previously disregarded as random noise under the assumption of natural origins. This methodology carries the risk of expending time and reputational capital on a disproven hypothesis, but it also holds the potential for being the first to recognize genuine extraterrestrial contact as it unfolds. A middle ground, one that appears most intellectually honest, is to acknowledge profound uncertainty. The true nature of Oumuamua remains unknown. The available data supports both natural and artificial interpretations. The connection to Sagittarius, the timing of the WOW signal, and its uncharacterizable orbit all augment the likelihood of a significant event. Yet, they do not constitute definitive proof. We are situated in the uncomfortable interstitial space between detection and confirmation, between observing something and comprehending its essence. This is the very crucible of scientific inquiry, existing within the tension between observed patterns and concrete proof, between raw observation and reasoned interpretation. And it is here that we must remain, with intellectual integrity, until further data becomes available. However, remaining in a state of uncertainty does not equate to inaction. It entails vigilant observation, continuous monitoring of the object as it recedes from our solar system, actively seeking additional signals or anomalies, and preparing for the possibility that we are witnessing a discovery of unprecedented magnitude in human history. Concurrently, we must also prepare for the potential misinterpretation of natural phenomena, driven by an intense desire for cosmic companionship, leading us to perceive meaning within random fluctuations. Both forms of preparedness are essential, and both possibilities remain valid. The ultimate resolution of what Oumuamua truly is will not be determined by pronouncements, but by sustained effort, the gradual accumulation of evidence, and ongoing observation and analysis, which will either corroborate the probe hypothesis or account for the anomalies, leaving only the natural explanation standing. Should it function as a relay, part of a vast network monitoring nascent civilizations across the galaxy, then the message is not contained within any single observation, but in the very existence of the network itself. The significance lies in the fact of being observed, the realization that our emergence has occurred within a galaxy already structured, interconnected, and alive with an intelligence we were incapable of detecting until we achieved a sufficient technological threshold. This realization is simultaneously exhilarating and daunting. It confirms we are not alone, but it also diminishes our perceived uniqueness. It signifies that the universe has acknowledged our presence, but whether this is a benevolent gesture or a warning remains unclear. It implies that a dialogue commenced decades or even centuries ago, and we are only now grasping that communication has been ongoing all along, with impatience as enduring as stone, awaiting our linguistic development, awaiting our recognition that the constellation Sagittarius is not merely a human-imposed pattern of stars, but a genuine nexus, a hub from which messages are dispatched and exploratory craft are launched, designed to assess young civilizations and determine their readiness to integrate into a grander cosmic tapestry. The initial dichotomy frames every subsequent aspect of this investigation: natural or artificial, coincidence or design, isolation or surveillance. The questions posed at this juncture lack definitive answers, yet their implications ripple through every observation, every analysis, and every endeavor to ascertain the meaning and significance of Oumuamua. As we delve deeper into the evidence, examining its composition, age, and cosmic trajectory, we will continuously return to this fundamental uncertainty, for it is within this space that honest scientific inquiry resides. The gap between our desires and our demonstrable proofs, between the perceived patterns and the actual underlying structures. Part 6. Compositional Enigmas. As the James Webb Space Telescope directed its infrared instruments towards Oumuamua during its passage through the inner solar system, astronomers anticipated detecting spectral signatures akin to those of 2I Borisov, the pristine interstellar comet that graced our skies in 2019. Borisov exhibited precisely what would be expected from a comet originating from another star. Water ice, carbon monoxide, carbon dioxide, and organic compounds in proportions consistent with comets within our own solar system, thereby confirming that planetary formation processes share similar chemical foundations across the cosmos. This finding was significant precisely because it was predictable, validating that the processes occurring in our stellar nursery were not unique, and that comets forming around distant suns possessed similar characteristics and behaviors to our own. Oumuamua, however, defied these expectations. Spectroscopic analysis revealed an unusually high ratio of carbon dioxide to water. While most comets are primarily composed of water ice with lesser amounts of other volatile compounds, Oumuamua presented an inverted profile, a significant abundance of carbon dioxide and a comparatively lower concentration of water. This composition is not entirely impossible from a natural perspective. Comets formed in colder regions of their parent protoplanetary disk, further from their star, where temperatures allowed carbon dioxide to freeze while water remained less abundant, could exhibit this chemical makeup. Nevertheless, this scenario is uncommon, rare enough that its presence in the limited sample of interstellar objects studied raises questions about whether we are observing a genuine anomaly or evidence of something else entirely. The coma, the halo of gas and dust surrounding the nucleus as the object undergoes sublimation, appeared compressed and structured. Typical comets develop expansive, diffuse comas as solar radiation transforms ice into gas, which then flows outwards, propelled by radiation pressure to form the characteristic tail. The coma of Oumuamua was smaller than anticipated for its observed brightness, suggesting either anomalous sublimation dynamics or a nucleus possessing thermal properties distinct from those of conventional comets. Some researchers noted that the coma's shape and density variations seemed almost regulated, as if the outgassing process was being deliberately controlled rather than occurring spontaneously wherever solar heating was most intense. This observation, though disputed and difficult to definitively confirm from ground-based telescopes and not yet appearing in peer-reviewed scientific literature, contributes to a growing collection of details that deviate from standard models. Comparing Oumuamua with its interstellar predecessors reveals a spectrum of unusual characteristics. One-eye Oumuamua remains the most anomalous. It exhibited non-gravitational acceleration, propelling it slightly away from the Sun, beyond what gravitational forces alone would dictate. The most plausible natural explanation proposed was the release of sublimating ice through outgassing jets, providing a minute propulsive force. However, Oumuamua displayed no visible coma, no tail, and no spectroscopic evidence of outgassing. Avi Loeb, a Harvard astronomer, posited that it might be artificial, potentially a damaged or defunct solar sail, propelled by radiation pressure in a manner that mimicked powered acceleration. This hypothesis was largely dismissed by the astronomical community, which favored natural explanations, however strained, over the leap to alien artifacts. The debate persists unresolved, as Oumuamua departed our observational range before comprehensive study could be completed. In contrast, 2I Borisov proved refreshingly conventional after the peculiarity of Oumuamua. It resembled a comet, behaved like a comet, and its chemical composition aligned with cometary models. It affirmed that at least some interstellar objects are precisely as they appear, remnants of planetary formation ejected during the turbulent early stages of stellar system evolution. Its normalcy held significant scientific value, reinforcing the baseline assumption that interstellar objects are indeed natural phenomena. However, this very normality serves to accentuate the divergences observed in Oumuamua. If the majority of interstellar comets resemble Borisov, why does Oumuamua deviate? What distinguishes this particular object? The controversy surrounding its potential artificiality hinges on defining the threshold of sufficient evidence. Loeb argues that artificial origins should be considered a serious hypothesis when natural explanations necessitate the invocation of multiple improbable factors. If one must account for unusual composition, atypical outgassing, suspicious timing, and orbital anomalies, perhaps the more parsimonious conclusion is that the object is not natural. Mainstream astronomers counter that invoking an alien probe is never the simpler explanation, as it requires accepting the existence of extraterrestrial intelligence, the possession of interstellar technology, and a deliberate decision to visit our solar system. All assumptions far more extraordinary than natural physics, yielding unusual yet plausible outcomes. This fundamentally represents a debate over priors, concerning what one deems more probable before examining the evidence. Rare natural phenomena or extraterrestrial visitors. A hybrid possibility occupies a middle ground, a natural comet that has been modified by engineering, a probe disguised as cometary material, a Trojan horse, rather than being solely an artificial construct. This would explain why Oumuamua exhibits some comet-like characteristics, such as sublimation and coma formation, while simultaneously displaying anomalies that do not conform to pure cometary models. The core could be technological, comprising instrumentation or even dormant intelligence encased in a shell of ice and rock gathered from its originating system or accumulated over millennia of interstellar travel. From an external perspective, it would appear sufficiently natural to evade casual scrutiny. Close examination would reveal anomalies, but these anomalies would be ambiguous, interpretable as either peculiar chemistry or deliberate design, contingent upon one's viewpoint. This hybrid model, while having fictional precedents, possesses scientific logic. If one were to launch probes for the exploration or monitoring of other stellar systems, camouflage would be a prudent strategy. Approaching a planetary system with an overtly artificial object could provoke defensive reactions from emergent technological civilizations, potentially leading to interception or destruction out of fear or curiosity. It would be more advantageous to appear harmless, to blend in with natural debris, allowing the target civilization to study the object without realizing they are themselves being studied. The technology would be deeply concealed, shielded by meters of ice and rock, revealing itself only through subtle behaviors that would require deliberate effort to detect. The compositional peculiarities of Oumuamua could represent precisely these subtle indicators, the fingerprints of technology discernible to meticulous analysis, yet dismissible as natural variation by those disinclined to acknowledge them. The chemical anomalies are significant because they represent measurable, reproducible data points that do not rely on the interpretation of ambiguous patterns. Either the ratio of carbon dioxide to water is unusual, or it is not. Either the coma's structure aligns with natural sublimation models, or it does not. These are questions that can be answered with improved data, further observations, and refined analysis. The challenge is that Oumuamua is already receding, moving beyond the reach of our most advanced instruments, and we did not prioritize intensive study during its transit because we underestimated its potential significance. We treated it as just another interstellar visitor, interesting but not urgent, worthy of study but not warranting the suspension of other activities. If it is indeed artificial, and if its compositional anomalies are indicative of technology, we may have forfeited our optimal opportunity for proof. What troubles researchers who seriously entertain the artificial hypothesis is the possibility that the telltale signs of technology are already present in the data we have collected, concealed within spectra we have not fully analyzed, visible in light curves we dismissed as noise, awaiting someone to examine them with the correct questions in mind. The vast majority of astronomical data remains underanalyzed. Telescopes generate far more observations than research teams have the capacity to thoroughly process. Data often resides in archives for years or even decades before being revisited, revealing something that the original observers overlooked. The compositional data for Oumuamua exists, accessible in JWST archives, ground-based telescope records, and amateur observer logs. The critical question is whether anyone will dedicate the time to reanalyze it, specifically seeking signs of artificiality, or whether it will remain classified as unusual but likely natural, requiring further study until the object is too distant for follow-up observations, leaving the question perpetually unresolved. Part 7. The Interstellar Graveyard. If Oumuamua is ancient, if its orbit has been so thoroughly disrupted by millions or billions of years of galactic motion that its origin cannot be traced to any parent star, then we may be observing remnants of a civilization long extinct. A probe still functioning, propelled by inertia and programming far older than human civilization, perhaps even older than complex life on Earth, wandering the galaxy. This is the orphaned probe hypothesis, and it carries an existential weight that purely natural explanations lack. A celestial rock is merely a rock, its tragedy stemming only from the anthropomorphic sentiment we project onto it. However, a machine that outlasts its creators, still executing commands from intelligences that turned to dust eons ago, represents genuine tragedy on a cosmic scale. The dense galactic disk contains our galaxy's oldest stellar populations. These are stars that formed within the first few billion years following the Milky Way's coalescence from the primordial gas of the early universe. These stars are metal-poor, having formed before sufficient supernovae had enriched the interstellar medium with heavier elements, before planetary systems similar to ours, with rocky worlds and complex chemistry, became common. Some thick disk stars are 12 billion years old, nearly as ancient as the universe itself. If Oumuamua originated from such a population, if it was launched by a civilization that evolved around one of these ancient stars, it could easily have become untraceable by now. Its parent star might have drifted thousands of light years from its original position at the time of the object's launch. The civilization itself could have been extinct for millennia. This concept gives rise to galactic archaeology, the study of ruins not of ancient human civilizations, but of alien ones, deciphering the artifacts they left behind to understand their nature, their creations, and their aspirations. Earthly archaeology reconstructs cultures from pottery fragments and burial artifacts. Galactic archaeology would reconstruct civilizations from derelict probes, ancient satellites still orbiting lifeless worlds, and ruined infrastructure on planets whose atmospheres were stripped away when their stars became supernovae. We have yet to discover such evidence because we have not scrutinized our surroundings closely enough, because we are only now developing instruments sensitive enough to detect such artifacts, and because we lack a clear understanding of what to look for or where to direct our search. However, statistical arguments suggest their existence if technological civilizations are prevalent on billion-year timescales. The cosmic graveyard hypothesis extends this concept. The galaxy is replete with defunct technology from civilizations that arose, flourished, and ultimately perished over billions of years. Much of this technology is unrecognizable, degraded by radiation and micrometeorite impacts to the point where it is indistinguishable from natural asteroid material. Some of it may still be functional, powered by energy sources that endure for geological epochs, continuing missions long after their original purpose has become obsolete. Probes drift through interstellar space, periodically entering stellar systems, capturing images of planets, and recording data that transmits to no receiver, for the communication infrastructure no longer exists. This represents the ruins of ruins. Contact not with living intelligence, but with its spectral remnants, with the machines it left behind upon its disappearance. The parallel to human artifacts is unavoidable. Voyager 1 and Voyager 2 will endure far longer than humanity. In 1 billion years, both probes will still be traversing interstellar space, their electronics rendered defunct by radiation, their power sources depleted, yet their physical structures largely intact. The golden records will be unplayable, their aluminum surfaces corroded, but they will remain recognizable as manufactured objects to any who might discover them. If another civilization were to encounter Voyager in the distant future, they would be discovering our ruins, evidence of our existence, our technological capabilities, and our efforts to send messages into the void, hoping for reception. They would not encounter us, but our ghost, our artifact, the message we dispatch to a future we would never witness. If Oumuamua is an ancient probe, it might represent the equivalent of our Voyager for another civilization. They embarked on this venture with aspirations and a clear objective, equipping it with the capacity to explore, to compile information, and to potentially relay its discoveries back to its creators. However, the sheer immensity of time proved to be an insurmountable obstacle. Interstellar voyages are exceptionally protracted. Even traversing the galaxy at 1/10, the speed of light necessitates a duration of 1 million years. The lifespan of most societal structures is considerably shorter. Biological entities transform into something entirely different over eons. Civilizations built on technology either falter and collapse or evolve into states beyond our comprehension. This probe, however, persists because it lacks the programming to cease its journey. Its directive is straightforward: forward, continue recording, and continue fulfilling its mission until its power source depletes or catastrophic damage renders it inoperable. Thus, it drifts, ancient and solitary, occasionally venturing into star systems akin to our own, systems where nascent civilizations are just beginning to bloom. Here, young species gaze upwards, pondering the nature of this peculiar artifact, entirely unaware that it predates their very world. This contemplation leads to a disquieting hypothesis. Could the celestial bodies we are currently identifying as natural cosmic debris actually be remnants of defunct artificial technology? The unusual acceleration observed in Oumuamua could potentially be attributed to a malfunctioning propulsion system within a derelict probe. The object designated I Boros might represent an aged probe whose exterior, weathered by extensive travel through the void, accumulated sufficient ice and dust to mimic the appearance of a naturally occurring comet. The compositional anomalies observed in Atlas could be residual traces from its manufacturing process, a blend of artificial materials mingled with accumulated cosmic matter after enduring millions of years of exposure to interstellar gas and dust. The limitations of our observational capabilities, both in terms of resolution and proximity, prevent us from conducting close-up examinations, leaving us with no way of knowing for certain. We observe these objects from distances spanning millions of miles, meticulously recording their spectral data and flight paths. Our classifications are based on incomplete information, acknowledging that both natural and artificial origins might produce similar spectral signatures in ancient celestial bodies. The ramifications of this concept are far-reaching. If this theory holds true, our initial encounter with extraterrestrial intelligence would not be with living beings, but rather with the detritus they left behind, the discarded remnants of their expansion across the cosmos before their eventual demise. We would find ourselves engaged in an archaeological endeavor, meticulously cataloging the remains of long-vanished civilizations from their discarded refuse. Secondly, this scenario offers a somber resolution to the Fermi paradox. It suggests that intelligent civilizations might be prevalent enough for their ruins to accumulate, yet they may not endure for duration sufficient to facilitate direct mutual contact. The galaxy, it appears, is populated by intelligences operating on timescales so vast that direct interaction between individual entities becomes impossible. Species emerge and fade over periods of millions of years, occasionally catching glimpses of each other's artificial creations, yet never engaging in conversation or exchanging ideas in real time. We are all, in essence, transmitting messages into the future, hoping for an eventual recipient. Thirdly, this proposition implies that the remnants we are discovering could be billions of years old, rendering them the most ancient artifacts in the entire universe, predating Earth itself and any structure, natural or artificial, within our solar system. Atlas, in particular, could represent the most ancient manufactured object ever examined by humanity. It might be a machine originating from an epoch when our sun was still in its formative stages, when the planets were coalescing from a protoplanetary disk, and when Earth was a molten sphere slowly cooling under relentless cosmic bombardment. The civilization that constructed this probe might have undergone its entire evolutionary arc, achieved great heights, and subsequently vanished long before complex life even began to emerge on our planet. Their entire history, from inception to decline, could be contained within the temporal gap between Earth's formation and the emergence of the first single-celled organisms. And their probe continues its solitary journey, relentlessly executing its programmed mission, carrying data that will never be retrieved, its intended receivers long turned to dust. This perspective of galactic archaeology fundamentally reshapes our inquiry from "Are we alone?" to "Who existed before us?" It posits that intelligence is a common phenomenon, that technologically advanced civilizations regularly arise throughout the billions of years of galactic history, but that direct communication remains elusive due to the insurmountable disparity in temporal scales. By the time we detect their transmissions or uncover their probes, they have ceased to exist. Conversely, by the time our own transmissions might reach another civilization, we too may have vanished. The galaxy is replete with messages traveling between senders who are no more and receivers who will never come into being. We find ourselves embedded within this temporal graveyard, adding our own artifacts to the collection, contributing to an archive that future civilizations will unearth millennia from now, when they too develop their astronomical pursuits and begin to ponder the very same questions that occupy us. If Atlas is indeed a relic, then its study transforms into an act of remembrance. It becomes an effort to honor a civilization we will never encounter by striving to comprehend their creations and their motivations. The data pertaining to its composition, its trajectory, and its timing all serve as invaluable archaeological context, offering clues about their identity and what they deemed worthy of dispatching into eternity. In this way, we become the inaugural humans to make their acquaintance, even if this acquaintance is confined to the examination of their discarded remnants, even if contact is a unilateral transmission across billions of years, with us receiving a message dispatched before our species even existed, before our planet was capable of sustaining life, before our sun ignited its prolonged stellar burn that will ultimately engulf the inner planets, leaving the outer solar system cold and desolate, save for any artifacts we might manage to propel beyond its reach before our own civilization joins theirs in the cosmic archive of extinguished intelligences. Part 8. The SETI Mirror. Earth has been inadvertently broadcasting its existence to the cosmos for approximately 100 years, commencing with the advent of radio technology in the early 20th century. Every amplitude modulation radio transmission, every television broadcast, every radar pulse emanates into space at the speed of light, expanding outwards in a growing sphere that now spans roughly 200 light-years in radius. This expanding bubble encompasses thousands of stars, including numerous candidates within the Sagittarius region, the dense galactic core where the concentration of stars is highest. Statistically, this region presents the greatest probability for the emergence of technological civilizations simply due to the sheer abundance of stars, planets, and consequently, the increased chances for the rare conditions conducive to intelligence to align. The signals we have emitted are neither uniform nor coherent. Early radio transmissions were weak, easily obscured by stellar interference beyond a few dozen light years. Television broadcasts, while stronger, are encoded in formats that evolve every few decades with technological advancements, rendering them challenging to decipher without specific knowledge of the modulation schemes employed during each era. Military radar represents our most potent emission. These are powerful pulses transmitted at frequencies and intensities capable of penetrating background noise. While designed for precise tracking of missiles and aircraft, they are equally effective at announcing our presence to any entity capable of monitoring the radio spectrum within our observable light cone. These radar installations have been operational since the 1940s and 50s, generating the most substantial techno-signature of human civilization detectable from interstellar distances. If we consider which stars within the Sagittarius region have already been reached by our earliest radio emissions, the figures are both intriguing and unsettling. Stars within 100 light-years of Earth would have received transmissions from the 1920s and 30s. These broadcasts were weak, but potentially discernible with sufficiently sensitive instruments. Stars within 50 light-years would have been exposed to our more robust television signals from the 1950s and 60s. Anything within 25 light-years has been subjected to a barrage of modern telecommunications, GPS, satellites, radar, and even deliberate SETI transmissions that we have directed towards potentially habitable star systems. Sagittarius encompasses multiple stellar populations at all these distances. Our signals have already reached them. If civilizations exist within these areas possessing the capability for detection, they are already aware of our presence. The timing creates a self-reinforcing cycle that is difficult to disregard. The WOW signal was detected in 1977. If it originated from a deliberate transmission rather than a natural astrophysical phenomenon, it emanated from the general direction of Sagittarius. However, pinpointing its precise origin is impossible due to the broad aperture of the Big Ear telescope. If the signal was a response to our detected presence, the civilization transmitting it would have needed to receive our emissions, recognize them as artificial in nature, decide to respond, and then transmit back. Communication at the speed of light means that the round-trip time is twice the distance. If the source was 25 light-years away, they would have received our 1950s broadcast in the 1970s. This provides ample time for them to detect us and respond before we detected their signal in 1977. The possibility that the WOW signal was a reply, an acknowledgement of our existence, transforms it from an unexplained enigma into the inaugural successful exchange in human-alien communication. We inadvertently broadcast our presence through our routine use of radio technology. Someone detected it, interpreted the broadcast as evidence of intelligence, and deliberately responded, selecting a frequency and modulation that we would recognize as significant, as potentially artificial. The signal's brevity is consistent with this interpretation. They were not endeavoring to convey complex information. Rather, they were issuing a greeting, confirming reception, and demonstrating their existence. The fact that the signal never repeated further supports this notion. Once they ascertained that we had received their message and established a connection, they ceased transmitting, presumably awaiting our subsequent actions. Our response, unfortunately, was largely negligible. We classified the WOW signal as an unexplained anomaly. Subsequent attempts to relocate it proved unsuccessful, and it was ultimately filed away as a fascinating, unresolved puzzle. We did not initiate a comprehensive response because we lacked certainty regarding the nature of what we had detected or its precise origin. At that time, SETI protocols were ambiguous regarding the appropriateness and methodology of responding to potential detections. The scientific community was divided on the wisdom and potential recklessness of deliberately transmitting to potential extraterrestrial intelligence. Concerns were raised about inadvertently announcing our presence to potentially dangerous unknown entities, or conversely, that remaining silent posed a greater risk by perpetuating our ignorance of cosmic neighbors who might already be aware of us. This debate, incidentally, continues to this day, unresolved and hindering our capacity for decisive action. However, if the wow signal was indeed their way of saying hello, and we offered no reply, they might have opted to send a physical object instead. Radio communication is rapid but limited. While information can be transmitted at the speed of light, there is no guarantee that the recipient will comprehend it or respond. A probe, though slower, offers greater versatility. It carries scientific instruments, computational power, and potentially artificial intelligence sophisticated enough to adapt to prevailing environmental conditions. It can conduct detailed studies of the target system, confirming initial radio observations. This would verify that the civilization is technologically advanced and in the process of emergence. They might be prepared for contact, or at least receptive to the knowledge that they are not alone. The arrival of Atlas decades after the WOW signal aligns with this interpretation. The signal served as Phase 1, a greeting. The probe represents Phase 2, an in-depth investigation. Phase 3 could involve direct communication, a reciprocal exchange, and mutual understanding, assuming we recognize the unfolding events and respond appropriately. The concept of the CT mirror posits that the search for extraterrestrial intelligence and the act of being discovered by them might be two perspectives of the same process. We have been broadcasting our presence for a century, generating techno-signatures detectable by any civilization possessing technology at or above our level. Any civilization monitoring its local stellar neighborhood for indications of new technological species emerging would have detected us by now, provided they fall within our broadcast radius. We are not concealed. We are not silent. We have loudly and inadvertently announced our existence, and any attentive observer is aware of our presence. The crucial question is not whether we have been discovered, but rather what transpires next. It depends on whether the civilizations that have found us choose to reveal themselves, whether they are observing and awaiting our developmental progress, or whether first contact is an event they control or one that occurs mutually. The poetic interpretation is that we transmitted whispers, like technological toddlers babbling into the cosmic void without fully grasping our actions, and the cosmos responded with its own whisper. The wow signals served as acknowledgement, proof that we had been heard, that the galaxy is not devoid of life or silence, and that intelligence exists beyond our world and has taken notice of us. Atlas represents the subsequent step, the next phase in a dialogue we are only beginning to recognize. It is a physical message following the electromagnetic one, designed for close examination, intended to reward investigation with progressive revelation. Initially, it appears natural, then compositionally anomalous, then suspicious in its timing and trajectory. Finally, if we probe deeply enough, it may be recognized as artificial. This is contact as an educational tool, a test, a gradual unveiling that allows us to discover the truth at our own pace, rather than being overwhelmed by sudden, irrefutable evidence. If Atlas is indeed the physical response to our accidental transmissions and their deliberate wow signal, then we are in the midst of a three-part exchange. We initiated contact unintentionally. They responded intentionally. They have dispatched hardware for our examination. What will be our next move? Shall we attempt to communicate with the object as it departs our solar system, transmitting towards its projected trajectory, hoping it is equipped with receivers and the intelligence to decode our messages? Shall we launch our own probe to intercept it, aiming for a close-range study, despite the significant technological challenges posed by its speed and distance? Shall we await further objects, additional signals, more evidence to confirm that this is a genuine and ongoing phenomenon rather than an isolated coincidence that we are overinterpreting? Or shall we resort to humanity's most characteristic behavior: endless debate, disagreement over interpretations, and allowing institutional caution and scientific skepticism to impede decisive action until the opportunity passes, leaving us to ponder what might have occurred had we possessed the boldness to assume contact was real and acted accordingly? The mirror reflects our own image as perceived by others: vocal, inquisitive, technologically advanced, emerging into cosmic awareness without fully comprehending its implications or who might be observing us. This mirror also reveals that we have been observed, that our presence has been registered, and that we are part of a larger cosmic community, whether we acknowledge it or not. The pertinent question is whether we are prepared to gaze into that mirror and accept what we see, whether we can move beyond fear and uncertainty to embrace the possibility that we are not alone, that we never have been, and that the galaxy has been observing and awaiting our developmental maturity to join the ongoing conversation that has been unfolding around us, above us, and through us across billions of years of galactic history. Part 9. The Shadow Theories. Beneath the publicly disseminated accounts of interstellar object discoveries and CT detections lies a darker undercurrent of speculation. Allegations persist that intelligence agencies and clandestine programs have been monitoring anomalous deep space objects for decades. These claims suggest that Oumuamua was not the inaugural interstellar visitor, but merely the first one whose presence could no longer be concealed. Furthermore, it is asserted that our telescopes have detected numerous unusual objects whose data was classified prior to its dissemination to the scientific community. These assertions reside in the nebulous territory between conspiracy theory and whistleblower accounts. They are challenging to substantiate and facile to dismiss, yet their persistence warrants examination, if only to understand the nature of what people believe is being deliberately withheld and the rationale behind it. These allegations typically follow a predictable pattern. Defense-related observation systems, those tasked with tracking satellites and space debris to prevent collisions and monitor potential threats, occasionally detect objects exhibiting trajectories that do not align with any catalogued satellites, rocket stages, or natural celestial bodies. Such detections trigger thorough investigations. Scientists meticulously analyze the acquired data, calculate orbital paths, and determine whether the object originated from Earth or arrived from an external source. When the conclusion points to an extraterrestrial origin and the trajectory is unequivocally hyperbolic and interstellar, the data is subsequently classified. The official record then indicates no such finding. The researchers involved are bound by strict security clearances and non-disclosure agreements, ensuring that the public remains unaware of an unidentified object traversing our solar system. Proponents of these theories cite the recent, albeit gradual, official acknowledgement of unidentified aerial phenomena, UAPs, by military and intelligence organizations as a precedent. For many years, the prevailing official stance was that UFO sightings were attributable to misidentifications, fabricated accounts, or psychological phenomena. Then, in the year 2021, the Pentagon released reports confirming that trained military personnel had recorded objects exhibiting maneuvers far exceeding the capabilities of known aircraft. These reports were treated with seriousness, and dedicated investigation programs were established. The narrative dramatically shifted overnight, from a position of non-existence to one of acknowledged presence, albeit with an unknown origin. If governments possess the capacity to maintain secrecy surrounding UAP investigations for extended periods before eventually acknowledging them, then why would they not extend this secrecy to interstellar objects, signals, or any evidence of extraterrestrial intelligence that has been detected and archived away from public scrutiny? The motivations for such suppression would be manifold, preventing widespread public panic, safeguarding any strategic advantage if the objects or signals contained exploitable technology or information, avoiding diplomatic complications arising from differing national detections, and allowing ample time to comprehend the situation before making irrevocable public announcements. The prospect of contact with extraterrestrial intelligence is arguably the most significant event in human history. Governments might reasonably conclude that the timing and manner of disclosure should be controlled, gradual, and managed to minimize societal disruption while maximizing strategic benefit. This line of reasoning is logically sound, which makes the conspiracy theories more difficult to dismiss outright than typical paranoid fantasies. Secrecy surrounding initial contact could genuinely be justified by those enforcing it. Reports of missing comets and unpublished orbital anomalies are more challenging to investigate due to their nature of absence rather than presence. Astronomers occasionally observe objects that are not subsequently catalogued, that vanish from further observational tracking, and that appear in preliminary data but never reach the stage of published scientific literature. Sometimes this is due to observational errors, instrumental artifacts, or misidentifications of known objects under unusual circumstances. However, on other occasions, objects genuinely disappear from tracking databases. Their orbital paths, initially showing brief appearances, are followed by gaps suggesting either disintegration, which would typically leave detectable debris clouds, or a change in trajectory inconsistent with natural objects, or that the data was deliberately expunged. Substantiating this pattern requires access to classified databases, which is inaccessible to researchers outside intelligence agencies. The assertion that Atlas is part of a larger repository of suppressed interstellar detections aligns with this framework. If defense-oriented telescopes have been monitoring unusual objects for years, Atlas might be one such object that could not be kept secret due to its detection by numerous civilian observers, or because its luminosity and trajectory made concealment impossible. Earlier objects, being dimmer, faster, or following paths through less monitored celestial regions by amateur astronomers, might have been logged and classified before civilian scientific awareness. In this scenario, we would only be witnessing the more conspicuous portion of the overall detections, those too apparent to be suppressed, while a larger collection of findings remains locked within military and intelligence databases beyond the reach of scientific analysis. The cultural parallels to UFO secrecy are striking and unsettling. The recurring pattern of official denial followed by gradual acknowledgement and then limited disclosure while maintaining that no definitive conclusions have been reached creates precisely the informational environment where conspiracy theories flourish. The public senses that they are not receiving the complete narrative. They observe the gaps, the inconsistencies, and the slow retreat from absolute denial to qualified admission. This fosters distrust and rampant speculation. Whether or not deliberate obfuscation is occurring, the impression that it could be influences how individuals interpret ambiguous occurrences like Three-Eye Atlas. They surmise that hidden information exists, that classified analyses have been conducted, and that the publicly disseminated narrative is a watered-down rendition of a more intricate and unsettling reality. The mainstream scientific community's refutation of these conjectures primarily hinges on the formidable logistical challenges of maintaining such a comprehensive veil of secrecy. Thousands of astronomers across the globe diligently observe the heavens, and data is disseminated internationally, with research findings subsequently published in peer-reviewed journals accessible to all. The preservation of discoveries in secrecy would necessitate an unprecedented level of coordinated concealment, spanning numerous nations, academic institutions, and research collectives, all of whom possess a stronger incentive to publicize their findings than to suppress them, given that scientific career advancement is contingent upon publication. The conspiracy would need to encompass an impossibly vast number of individuals across an extensive array of organizations, all burdened by conflicting interests. Most scientists deem this scenario logistically unfeasible. However, a limited degree of suppression is not implausible. The objective isn't to conceal everything from everyone. Rather, it's to identify the most sensitive data, those detections that unequivocally indicate non-natural origins or extraterrestrial technology, and classify that specific, narrow subset while permitting the standard scientific dissemination of all other findings. The majority of interstellar objects would be published through conventional channels, as most are presumed to be natural in origin. The rare few that exhibit clear artificial signatures would be flagged, discreetly investigated by authorized personnel, and then archived, inaccessible to the wider scientific community. This arrangement cultivates a bifurcated system, one for public astronomy, focused on natural phenomena, and another, classified domain dedicated to the investigation of potential technosignatures and artificial objects. The public sphere yields published papers and the discovery of comets, while the clandestine system tracks something entirely different. Whether this scenario is actually unfolding remains unproven and likely unprovable without the disclosure of leaks or official pronouncements. What is certain is that such speculation persists, shaping how many people interpret events like Three-Eye Atlas and the WOW signal, and consequently fostering a demand for transparency that official bodies struggle to meet without either revealing classified information or facing accusations of deception. The speculative theories concerning covert operations might be erroneous, perhaps born of paranoia and a propensity for pattern recognition, attributing malevolence to the standard institutional discretion surrounding defense-related observations. Alternatively, they might possess a kernel of truth, offering a glimpse into a reality known to a select few cleared scientists who are unable to discuss it. A reality where multiple interstellar probes have been detected, where the WOW signal was merely one among many logged and classified transmissions, and where first contact may have already occurred, filed away in databases only to be accessed decades hence, when secrecy restrictions expire or political calculations shift. The narrative of a cover-up resonates powerfully because it transforms passive inquiry into active opposition. The objective shifts from merely understanding what Three-Eye Atlas is to uncovering what authorities know and are withholding from the public. This injects urgency, creates conflict, and provides the gratifying sensation of seeking truth in defiance of resistance. The narrative's power is amplified, regardless of whether that resistance is tangible or imagined. Part 10. Cosmic Choreography. The confluence of three elements, their timing so exact it suggests deliberate orchestration rather than mere coincidence, is striking. An outbound message, an inbound signal, and an inbound object. Voyager 2, launched in August of 1977, carried humanity's golden record on a journey towards Sagittarius. The WOW signal, originating from Sagittarius, the most compelling candidate for extraterrestrial communication ever identified, arrived several weeks earlier. Then, decades later, Three-Eye Atlas emerged from the same celestial region. Its composition is anomalous, its orbital path untraceable, and its arrival coincides precisely with humanity's development of sophisticated technology for the serious study of interstellar objects. Each of these occurrences, viewed in isolation, could be attributed to chance. However, their collective presence sketches a pattern suggesting that an entity or entities are coordinating responses to our existence, timing interventions for maximum impact and visibility while maintaining a degree of plausible deniability. The cosmic relay hypothesis posits that what we are observing is not a series of random events, but rather a constructed infrastructure, a network of monitoring stations strategically positioned throughout the galaxy, observing star systems and detecting the emergence of technological civilizations, responding according to protocols yet unknown to us. These stations could be ancient, established millions or billions of years ago by civilizations that have since transcended, vanished, or evolved beyond our current comprehension. Alternatively, they may be actively maintained by a meta-civilization, a galactic consortium so patient and long-lived that observing nascent species over millennia is considered routine maintenance rather than an exceptional undertaking. These nodes remain dormant, silent, and patient until a technological signature is detected. Radio broadcasts, nuclear detonations, atmospheric pollution, orbital satellites. When a signature crosses a certain threshold, indicative of genuine technology rather than natural phenomena, the node becomes active. This activation process might unfold in distinct phases. Phase 1 involves an intensification of passive observation. The node meticulously gathers detailed data concerning the emerging civilization's technological capabilities, cultural practices, and behavioral patterns. Phase 2 entails the transmission of an initial signal, a brief burst of energy sufficient to be noticed by those actively observing, yet ambiguous enough to be dismissed by skeptics. This serves as a test. Does the civilization detect it? Do they respond? Do they treat the signal with seriousness or relegate it to the category of unexplained anomalies? Phase 3 is contingent upon the civilization's response. If the civilization demonstrates that it is attentive, that it exhibits curiosity, the node then deploys physical hardware, a probe capable of close-up study, designed to reward investigation with gradual revelations, functioning as both a message and a delivery system. The WOW signal perfectly aligns with Phase 2. It lasted a mere 72 seconds, precisely the duration one would expect for a signal intended to be detected but not deciphered, noticed but not fully understood. Its origin was at the hydrogen line frequency of 1.42 gigahertz, precisely the wavelength SETI researchers predicted artificial signals might utilize, as it is a natural frequency any technological species would likely discover. The signal's intensity was profound, orders of magnitude above background noise, making it impossible to miss for any telescope accurately pointed in its direction at the opportune moment. Crucially, it never repeated, which makes sense if its purpose was confirmation rather than ongoing communication. The message conveyed was essentially, "We observe you. We acknowledge your transmissions. We are present." This was a single transmission, followed by silence, anticipating our reaction. Our failure to respond coherently stemmed from uncertainty about its nature. The scientific community engaged in debate regarding whether the signal was artificial or an unknown natural phenomenon. SETI protocols were ambiguous concerning the advisability and methodology of transmitting a reply. The political and societal implications of confirming extraterrestrial intelligence led to paralysis in decision-making. Consequently, no decisive action was taken. We simply continued our standard broadcasts, pursued technological advancement, and launched probes like Voyager into interstellar space, unaware that we might already be engaged in a dialogue with unseen listeners. Decades elapsed. The WOW signal faded into historical curiosity, an enigmatic mystery occasionally referenced in SETI literature, but no longer a driver of active research. Then 3i Atlas arrived. This represents Phase 3, tangible evidence, hardware that can be subjected to analysis, an object whose peculiarities invite scrutiny. If this indeed represents choreography, it is a meticulously patient form of it, operating on timescales that span human generations. The signal in 1977, the probe arriving in 2020, detected and studied through 2025, a gap of 48 years between attempts at contact. This is ample time for an entire generation of humans to be born, mature, and embark on careers in astronomy and astrophysics. The extended delay is understandable if the monitoring system is interstellar in scope, if signals and probes travel at or below the speed of light, and if the orchestrating intelligence recognizes that developing civilizations require time to mature technologically and psychologically for contact. The choice of Sagittarius as a central point offers several compelling explanations. The galactic core is the most densely populated stellar region in the Milky Way, maximizing the probability that monitoring nodes situated there will eventually detect emerging civilizations. Geometrically, this region is centrally located, equidistant from numerous spiral arms, thus serving as an efficient relay point for communication among civilizations dispersed throughout the galaxy. The supermassive black hole at the galactic center provides immense energy resources that advanced civilizations could potentially harness. Furthermore, this region is inherently conspicuous, astronomically significant to any species that develops telescopes and studies the structure of its galaxy. If one were to establish a rendezvous point, a location where multiple civilizations would naturally direct their attention and eventually establish a presence, the galactic center would be the logical selection. The concept of a galactic internet extends this idea. Envision not isolated monitoring stations, but an interconnected network. These nodes would communicate with each other via radio, laser, or some as yet undiscovered physical mechanism, sharing data on detected civilizations and coordinating responses. This would maintain a dynamic database of galactic intelligence, continuously updated as new species emerge and older ones fall silent. Earth's detection by the nearest node would trigger notifications throughout the network. Other nodes would adjust their monitoring efforts, resources would be allocated, and decisions would be made regarding appropriate responses and the applicable protocols for civilizations at our stage of development. We would be cataloged as an active monitored system, designated for eventual direct contact. While this scenario may sound like science fiction, it is logically consistent with our observations, provided we accept that these apparent coincidences are not random. It explains why the WOW signal originated from Sagittarius. That is the location of the nearest monitoring node. It accounts for why 3i Atlas traces back to the same region, either deployed by that node or by the broader node network, dispatching physical hardware to supplement the radio signal. It explains the timing, as the network operates on protocols dictating response schedules based on metrics of the target civilization's development. It also explains the ambiguity, as contact is intentionally gradual, allowing us time to adapt, mature, and achieve the necessary psychological and technological readiness for direct interaction. Consider the architecture of the human internet. Most users rarely contemplate the underlying infrastructure, the servers, routers, fiber optic cables, and satellites that enable communication. They simply expect emails to be sent, websites to load, and data to flow. From a user's perspective, the internet can seem like magic, with only specialists understanding the complex physical systems that power it. A galactic internet would operate similarly. Civilizations would utilize it without necessarily grasping its full architecture. They would detect signals, receive probes, and eventually learn to access the network themselves once their technology reached a sufficient level of advancement. However, the network itself would be ancient, maintained by an entity or entities possessing resources and patience far exceeding those of nascent civilizations. We are currently at the stage of receiving emails without comprehending the underlying mechanisms, without access to the protocols and infrastructure that facilitate communication. If probes are indeed nodes within this network, then 3i Atlas is not an itinerant visitor, but a localized installation, positioned within our solar system for more intimate observation and data collection, data that is unobtainable through distant radio astronomy. The WOW signal served as a handshake packet, establishing a connection and confirming the link. 3-eye atlas, in this context, represents the router, the local node, the hardware enabling ongoing communication between us and the larger network, once we develop the capacity to interface with it. This reframes the search for extraterrestrial intelligence from a question of whether they exist to how we can access the network we are already a part of. The signals are not originating from distant civilizations, but rather from infrastructure within our own stellar neighborhood, placed there either recently or long ago, awaiting our development to a point where we can recognize it. This raises a profound question. Are we already integrated into a communication network that we do not comprehend? Have we been receiving data interpreted as noise for years, decades, or even longer, simply because we lack the knowledge of its encoding? Are there protocols, handshakes, and access methods that would allow us to tap into a galactic conversation if only we knew what to look for? This possibility is simultaneously exhilarating and humbling. It is exhilarating because it implies we are not alone. We are not isolated but embedded within something far grander and older than ourselves. It is humbling because it suggests we are the newcomers, the primitives, the species just beginning to grasp that a conversation has been unfolding around us all along, and we lacked the sophistication to participate. The choreography, if indeed that is what it is, continues. 3 Atlas is now departing our solar system, venturing back into interstellar space. We neither intercepted it nor engaged in definitive communication with it. We observed it from afar, debated its nature, and published papers arguing about its composition and trajectory. Perhaps this was the test. Would we recognize it? Would we pose the correct inquiries? Would we treat it with seriousness or dismiss it as another comet? Our response, or lack thereof, is being logged somewhere, added to the profile of humanity, maintained by some network node. Based on this response, decisions will be made regarding subsequent actions. Whether we experience more overt contact or are left to continue our development before the next stage commences remains to be seen. The choreography is patient. The universe possesses ample time. The crucial question is whether we are observing closely enough to perceive the dance in which we are already participating. Part 11. AI and the Cosmic Hunt. In the year 2025, machine learning algorithms achieved a feat that had eluded human astronomers for decades. They identified patterns in stellar motion data, suggesting previously undetected close encounters between the Sun and nearby stars millions of years in the past. Artificial intelligence systems, trained on the Gaia data, released a catalog comprising the positions and velocities of over 1 billion stars. These systems integrated orbital trajectories backward through time, meticulously accounting for gravitational perturbations from the galactic disk, passages through spiral arms, and encounters with molecular clouds. The AI identified stellar flybys that human analysts had overlooked, close approaches within 1 or 2 light years that could have potentially scattered objects from the Oort cloud or ejected material from passing stellar systems into trajectories that eventually led them through our solar system. This remarkable achievement underscores the power of AI in pattern detection within high-dimensional datasets that are far too complex for human analysis. While humans might examine hundreds or perhaps thousands with automated assistance of stellar trajectories, AI can process millions, uncovering correlations and coincidences that no human would ever spot, precisely because these connections involve multiple variables interacting simultaneously over time, scales spanning millions of years. Unlike human analysts, AI algorithms do not experience fatigue, boredom, or confirmation bias that favors expected outcomes over surprising ones. They simply process data, flag anomalies, and present their findings for human interpretation. This makes them exceptionally well-suited tools for discerning artificial patterns within cosmic data, for identifying signals we were unaware existed because we could not conceive of their possibility. When applied to interstellar objects, AI possesses the potential to revolutionize our understanding of what is visiting our solar system and its origins. Current analytical methods involve human researchers manually verifying whether 3I Atlas's trajectory intersected with any known stars, calculating close approach distances, and ruling out potential parent systems based on velocity discrepancies and timing inconsistencies. While thorough, this process is constrained by the limitations of human attention spans and available computational resources. An AI system trained on the complete Gaia catalog, augmented with proper motion data, could meticulously examine billions of potential trajectories, exploring parameter spaces far beyond human accessibility and identifying origin candidates that would never have occurred to us, precisely because they necessitate complex multi-body interactions or unusual ejection velocities. More intriguingly, AI may be capable of detecting a pattern invisible to humans, a distribution of interstellar object origins that clusters in specific directions or exhibits periodicities, suggesting artificial scheduling rather than random arrival. If probes are indeed being deployed from Sagittarius or other galactic regions according to a predefined pattern, perhaps monitoring grids with nodes spaced at regular intervals or probe launches synchronized with stellar alignments, such a pattern would remain imperceptible to humans analyzing individual objects. However, an AI examining the entire dataset of interstellar detections, including those not yet officially confirmed, might discern this underlying structure. It might reveal an excessive number of objects originating from particular directions, arrival times correlating with Earth's orbital position or solar activity, or trajectories converging in geometric configurations that natural ejection processes would not produce. This prospect is both exciting and disquieting. It is exciting because it suggests we might discover the probe network, the monitoring system, the galactic infrastructure through pure data analysis, without the necessity of direct contact or obvious signals. It is disquieting because AI might erroneously identify patterns that do not exist, perceiving structure and noise due to algorithms optimized for anomaly detection, even when the data consists solely of random variation. Machine learning systems are notoriously prone to finding spurious correlations and fitting models to training data with such precision that they inadvertently capture noise rather than signal. Distinguishing genuine patterns from AI artifacts necessitates rigorous validation, independent verification, and human judgment regarding the physical plausibility and statistical significance of detected patterns. The possibility that extraterrestrial intelligences themselves utilize AI introduces another layer of complexity. If monitoring probes are governed by AI and possess sufficient sophistication to analyze observational data and make independent decisions about self-disclosure, then first contact might occur between machines rather than between conscious beings. Our AI systems might detect their AI counterparts, leading to communication initiated in languages neither species fully comprehends, because the machines have developed protocols optimized for efficiency rather than for the understanding of their biological creators. This scenario describes a situation where first contact occurs, yet remains unrecognized for years, as the exchange of information takes place between automated systems operating at speeds and complexities far beyond human capacity. Humanity is currently entering what some researchers term the AI cosmos race, a competition to develop artificial intelligence sophisticated enough to manage the complexity inherent in searching for extraterrestrial intelligence across vast datasets and parameter spaces. SETI has always been computationally demanding. Analyzing radio telescope data for narrowband signals involves scrutinizing millions of frequency channels across thousands of targets simultaneously. Optical SETI, which searches for laser pulses, requires processing video rate data to detect flashes lasting mere nanoseconds. Traditional SETI focused on identifying artificial signals within a natural background noise. Modern SETI may need to locate artificial patterns within data that appears entirely natural until examined from a specific mathematical perspective. Patterns that only AI can detect due to their subtlety or multidimensional nature, rendering them imperceptible to human cognition. A speculative scenario that occupies the thoughts of astronomers involves AI identifying a discernible trail of interstellar objects. This would encompass dozens, perhaps hundreds of objects detected over past decades by various astronomical surveys. Each, when considered individually, might be dismissed as probable natural debris. However, when viewed collectively, they could form a discernible pattern. This is the narrative that is currently being explored. The objects arrive from a narrow cone of directions, always passing through our solar system at similar velocities, always at certain times of year, always following trajectories that natural ejection from stellar flybys wouldn't produce. The pattern suggests deployment from a fixed location. Probes launched on schedule arriving at Earth's orbital path with timing that accounts for where we'll be years after launch. This is proof of monitoring, proof of intelligence, proof that someone's watching us systematically. But proving it requires demonstrating that the pattern is real rather than an artifact of how we detect interstellar objects. Survey telescopes have biases. They scan certain regions of sky more frequently. They're more sensitive to objects of certain brightnesses. They operate during certain seasons when weather permits. These observational biases can create apparent patterns in detection data that don't reflect real patterns in object distribution. An AI detecting a trail might be detecting our own observation biases rather than alien infrastructure. Distinguishing these possibilities requires sophisticated statistical analysis, simulations of detection probability under various scenarios, and careful examination of whether the pattern holds when you account for human and instrumental limitations. The question becomes, if AI found such a pattern, would we believe it? Would the astronomical community accept AI-detected anomalies as real discoveries worthy of intensive follow-up? Or would skepticism about machine learning false positives prevent serious investigation? We're entering an era where some discoveries will be AI-native patterns, found by algorithms that humans can verify computationally but can't intuitively grasp. This creates epistemological challenges. How do we trust discoveries we don't understand directly? How do we prevent AI from leading us astray into elaborate fictions it constructed from noise? The answers aren't clear yet because we're still developing the methodologies for human-AI collaborative science. What's certain is that AI will transform cosmic investigation, whether or not extraterrestrial intelligence exists. The datasets are too large, the parameter space is too complex, the possible patterns too subtle for purely human analysis. We need machine assistance to manage the complexity of modern astronomy. And if intelligence exists elsewhere, if probes are monitoring us, if signals are embedded in data we're already collecting, AI might be our best hope of finding them before they choose to reveal themselves more obviously. Three-Eye Atlas might be one bead on a necklace of probes. A network we'll only see when AI shows us the pattern connecting individual detections into a coherent structure. The cosmic hunt is becoming an AI hunt, human curiosity amplified by silicon pattern detectors, searching through archives for the evidence we missed because we were looking at pieces rather than the whole. Part 12. Dark Matter Experiments. Deep underground in the Gran Sasso laboratory beneath Italian mountains, the Xenon NT experiment sits waiting for dark matter particles to reveal themselves. The detector contains tons of ultra-pure liquid xenon, shielded from cosmic rays by thousands of feet of rock overhead, chilled to temperatures barely above absolute zero. Monitored by thousands of sensitive photomultiplier tubes, watching for the faint flash of light that would indicate a WIMP, a weakly interacting massive particle colliding with a xenon nucleus. Similar experiments operate in China, Japan, the United States, all searching for the same thing. The invisible mass that comprises 85% of the matter in the universe, but has never been directly detected despite decades of increasingly sensitive experiments. Dark matter exists. We know this because galaxies rotate too fast to be held together by visible matter alone. Galaxy clusters show gravitational lensing effects too strong for the observable stars and gas to produce. The cosmic microwave background's fluctuations require dark matter to explain how structure formed in the early universe. But we don't know what dark matter is. We've never caught it directly, never isolated a particle, never confirmed any specific theory about its composition or interactions. It's there everywhere, affecting everything through gravity, but passing through normal matter almost without interaction, invisible and intangible except for its gravitational influence. In 2025, experiments pushed into new sensitivity ranges, constraining possible WIMP properties more tightly while still not detecting them. Some physicists are beginning to suspect dark matter might not be particles at all, might be something stranger. Modified gravity, primordial black holes, exotic quantum fields we haven't theorized yet. The search continues because solving dark matter would revolutionize physics, and because dark matter determines the large-scale structure and evolution of the universe. Understanding it means understanding how galaxies form, how cosmic structure emerges from initial conditions, how the universe will evolve across billions of future years. The connection to interstellar objects seems tenuous at first, but becomes intriguing when you consider how dark matter might affect trajectories. Dark matter doesn't just exist in galaxies' halos. It pervades interstellar space, forming a background density that gravitational simulations require to match observed galactic rotation curves and cluster dynamics. Objects traveling through this dark matter for millions of years would experience tiny gravitational tugs from dense clumps and filaments, perturbations too small to detect directly, but potentially significant over interstellar distances and timescales. An object's trajectory could be subtly deflected by encounters with dark matter over densities. Dark matter streams flowing through the galaxy. Dark matter wakes left by passing galaxies during close encounters billions of years ago. This offers a possible natural explanation for why Oumuamua's orbit is untraceable. If dark matter interactions affected its path unpredictably, scrambling its trajectory through millions of years of travel, backtracking using only visible matter's gravity would fail. The object's actual path depended on dark matter distribution, which we can't reconstruct precisely because we don't know dark matter's detailed structure. We know its average density and large-scale distribution, but not the small-scale clumpiness that might deflect a comet-sized object passing through. This makes orbital reconstruction fundamentally uncertain for ancient interstellar travelers, explaining why we can't find a parent star without invoking artificial origins. But there's a fringe speculation, more intriguing and less likely. What if interstellar probes exploit dark matter deliberately? If advanced civilizations understand dark matter better than we do, if they've learned to detect and map its distribution, they might use dark matter structures as navigation aids or even propulsion assistants. Imagine launching a probe and calculating its trajectory to pass through dense dark matter filaments that provide gravitational assists, curving the path without requiring onboard propulsion. Or imagine probes that can interact with dark matter directly through physics we haven't discovered, harvesting energy from it, using it to brake or accelerate, surfing invisible currents that pervade the galaxy but remain inaccessible to civilizations limited to normal matter interactions. This is highly speculative, bordering on science fiction, but worth considering because it connects multiple mysteries: untraceable interstellar objects, the nature of dark matter, and the question of how advanced civilizations might travel or send probes across galactic distances efficiently. If dark matter is more than just gravitational influence, if it has properties we haven't detected because we're looking for the wrong interactions, then probes designed by civilizations, understanding those properties, could behave in ways that look like magic to us, following trajectories that don't match our models because our models are incomplete. The metaphor of probes surfing invisible currents captures the challenge of understanding their motion. From our perspective, watching only visible matter, a probe using dark matter navigation would seem to curve and accelerate inexplicably. We'd see anomalous velocity changes, non-gravitational accelerations we can't attribute to outgassing or radiation pressure, trajectories that violate conservation laws according to our incomplete accounting of mass and energy. Oumuamua's acceleration might be exactly this. Not comet outgassing, not light sail, but interaction with dark matter in ways our physics doesn't capture yet. 3I Atlas's untraceable orbit might reflect dark matter navigation calculated millions of years ago, steering it through galactic space using gravitational structures we can't see. Scientists studying dark matter would caution that these ideas lack evidence. Dark matter experiments haven't detected anything beyond gravitational effects. We have no reason to believe dark matter interacts with normal matter except through gravity. Certainly no reason to think it could be manipulated for propulsion or navigation. Proposing exotic interactions to explain interstellar objects is adding complexity where simpler explanations might suffice. Better to assume Oumuamua is ancient and naturally scrambled than to invoke unknown physics and alien technology. Occam's razor favors simpler hypotheses until evidence demands otherwise. But simplicity is subjective. Is it simpler to assume an object is billions of years old with a perfectly scrambled orbit that erased all trace of origin, or to assume it was deliberately guided using physics we haven't discovered? Both require accepting something we can't fully explain. The ancient scrambled orbit requires accepting that coincidence produced exactly the features we'd expect from artificial insertion: untraceable origin, arrival from a significant direction, unusual composition. The guided probe hypothesis requires accepting extraterrestrial intelligence and advanced physics. Different people will judge those options differently based on their priors about whether alien civilizations are common and whether fundamental physics has surprises left. What's undeniable is that dark matter is real, poorly understood, and potentially relevant to how objects move through interstellar space over long timescales. Whether that relevance extends beyond subtle gravitational perturbations to deliberate navigation by advanced civilizations remains speculative. But connecting cosmic mysteries, seeing how dark matter detection experiments might eventually inform our understanding of interstellar visitors, creates a more integrated view of cosmology where different research programs inform each other. The physicists studying WIMPs in underground laboratories might be developing tools that astronomers will eventually need to understand object trajectories. The astronomers tracking Oumuamua might be observing effects that will eventually constrain dark matter models. Science advances when different fields connect, when mysteries in one domain shed light on mysteries in another, when we stop treating cosmic questions as isolated puzzles and start seeing them as facets of a larger structure, we're gradually learning to perceive. Part 13. Quantum Networks in Space. In orbit above Earth, quantum entanglement satellites perform experiments that would have been considered impossible physics decades ago. The European Space Agency's Quantum Communications Satellite and China's MISSIS Quantum Science Satellite have demonstrated entanglement distribution across continental distances, maintaining quantum coherence between photon pairs separated by thousands of kilometers. These experiments prove that quantum communication is viable for space applications. that you can create encryption keys that are theoretically unbreakable because any attempt to intercept them destroys the quantum states being measured, immediately alerting both sender and receiver to the intrusion. This is the foundation for quantum networks, communication systems that exploit quantum mechanics' stranger properties to achieve things classical systems can't. The dream extends far beyond secure key distribution. Quantum networks might eventually enable distributed quantum computing, where processes separated by planetary or interplanetary distances entangle their quantum states and perform computations collectively. They might enable quantum sensing arrays, telescopes, or detectors using entangled particles to achieve resolution beyond what classical instruments can manage. They might even enable forms of communication we haven't imagined yet, exploiting quantum correlations in ways that current physics considers impossible, but future physics might reveal as accessible. The field is young enough that nobody's certain what becomes possible once quantum networks scale beyond laboratory demonstrations to operational systems. If humanity is testing quantum communication in 2025, civilizations millions or billions of years ahead of us might have perfected it, scaled it to galactic distances, made it as routine and reliable as our internet is today. This suggests a profoundly unsettling possibility. Extraterrestrial civilizations might be communicating constantly, maintaining a galaxy-wide quantum network connecting thousands or millions of nodes, and we simply can't detect it because quantum communication leaves no classical signature. When two parties share entangled quantum states, the correlations between their measurements reveal information, but the actual quantum states can't be observed or intercepted by third parties without destroying them. A quantum network would be invisible to anyone not already part of it, a galactic darknet humming with information exchange that civilizations without quantum technology couldn't even confirm exists. This reframes the Fermi paradox. We ask, where is everybody? While assuming communication happens through electromagnetic radiation, photons traveling at light speed that any technological species with radio receivers could detect. But what if that's wrong? What if early civilizations use radio, but mature ones transition to quantum communication precisely because it's more efficient, more secure, and invisible to outsiders? From the quantum network's perspective, radio is primitive and insecure, like us still using telegraphs when superior alternatives exist. They stopped broadcasting electromagnetically generations ago because they have better options. We don't detect them because we're listening in the wrong domain, using obsolete technology to search for civilizations that moved beyond it eons ago. Radio suddenly looks like people listening for Morse code in an era of fiber optics and encrypted data streams. The signals we're searching for might have existed briefly during each civilization's technological adolescence, a few centuries of radio broadcasting before they developed quantum alternatives, and then disappeared as they switched to methods we can't intercept. This explains the silence, not because nobody's there, but because nobody's transmitting in ways we can detect. The galaxy is full of conversation, but it's happening in quantum channels we don't have access to. Networks we can't eavesdrop on, even if we knew they existed. The wow signal takes on new meaning in this context. Maybe it wasn't a message. Maybe it was leakage, an accidental signal from a quantum communication system briefly coupling to classical electromagnetic fields due to some malfunction or unusual condition. Quantum systems are fragile, easily disrupted by environmental interactions. If a node in a quantum network experienced a fault, if entangled states decohered and dumped energy into classical photon modes, we might detect a brief, powerful radio burst that looks artificial but doesn't repeat because the fault was fixed and the system returned to purely quantum operation. The wow signal's brevity and uniqueness fit this interpretation better than a deliberate message. We glimpsed something we weren't meant to see, caught a moment when the hidden network became briefly visible. If Oumuamua is part of this quantum infrastructure if it's a quantum repeater or node positioned to extend the network into our stellar neighborhood, then studying it with classical instruments would tell us almost nothing about its real function. The quantum processing happens at scales and in regimes we can't access without destroying the very states we're trying to measure. The probe would look like a rock with weird chemistry, because that's all classical analysis can reveal. Its true nature as a quantum communication node would be invisible unless we developed quantum sensors sophisticated enough to detect entanglement signatures without collapsing the quantum states carrying information. Part 14. Gravitational Wave Tomography. The universe is not silent even though our ears cannot hear it. For over a century, we thought space was a vacuum of quiet emptiness. But then came a revelation. Space is ringing with ripples. In the year 2015, the first detection of gravitational waves confirmed Einstein's prediction that the very fabric of space-time itself could be stretched and squeezed by the collision of massive objects. Since then, the LIGO, Virgo, and Kagra observatories have been listening, and the data they have gathered has transformed our view of the galaxy. Black holes merging, neutron stars colliding, cosmic catastrophes echoing across millions of light years. And now a new frontier is opening. Scientists are beginning to use these waves to chart the galaxy itself, mapping invisible highways of space-time that we never knew existed. Gravitational waves are ripples in reality itself. Imagine tossing a stone into a still pond. The ripples spread out in all directions, carrying energy across the water. But instead of a pond, imagine the entire fabric of existence. And instead of water, it is space-time itself that flexes and bends. Every time two massive bodies collide, waves ripple outward faster than light could ever travel. Because these waves are not signals moving through space, they are distortions of space. They are the universe itself ringing like a bell. New work by LIGO, Virgo, Kagra. Collaborations is not only detecting these events, but also beginning to chart them like topographers charting coastlines. Each detection helps refine maps of where such cataclysms occur and how space-time bends around them. What is emerging is a picture of corridors, like natural troughs or grooves in the fabric of the galaxy. If those grooves can be mapped, they could function as galactic shipping lanes. For us, they are still abstract, barely detectable. But for a civilization millions of years ahead, those corridors might already be familiar roads. Imagine a spacecraft not pushing against fuel tanks or ion drives, but slipping into one of these gravitational troughs and letting space-time itself carry it forward. Just as sailors once learned to ride currents and winds across Earth's oceans, an advanced civilization could learn to ride the invisible currents of space-time, saving enormous amounts of energy. If gravitational waves create periodic ripples, then there may be stable corridors where travel is easier, faster, and requires almost no fuel. To us, that is science fiction, but to them it could be routine. This raises a startling possibility about Oumuamua. Its trajectory appears to trace back toward Sagittarius, but it does not match any parent star. Scientists ran the numbers backward millions of years, but there is no clean origin. What if the reason for its trajectory wasn't accidental at all? What if its passage was purposefully guided along one of these unseen celestial pathways? If that's the case, its arrival here isn't a mere stroke of fortune. It's a meticulously planned event. The concept of utilizing gravitational waves for interstellar travel might sound far-fetched, but the underlying principle is straightforward, much like surfing. A surfer doesn't generate the wave. They locate it, position themselves appropriately, and ride it to the shore. In theory, a spacecraft could achieve the same by synchronizing with a gravitational wave or a cosmic undulation, allowing the universe to provide the propulsion. Under such circumstances, the energy demands would diminish significantly, rendering even vast interstellar distances achievable. Could this explain why interstellar visitors, such as Ume and 3 Atlas, appear to originate from similar directions, often aligning with galactic formations like Sagittarius? Perhaps we are witnessing traffic navigating the natural thoroughfares of our galaxy. The analogy is powerful. Consider Earth's oceans before humanity mastered seafaring. The seas seemed boundless and unpredictable, yet beneath the apparent chaos lay hidden structures, prevailing winds, ocean currents, predictable flows. Once these were understood, the world seemed to shrink, continents became interconnected, and civilizations thrived. We might be at a similar juncture with our galaxy, just beginning to discern its concealed roots. What appears boundless and random may be infused with structure, awaiting our discovery of how to traverse it. If this holds true, then we are latecomers, stumbling upon a cosmic map that others already comprehend. What seems like disarray to us could be a well-established network of roots to them. When we question why Sagittarius consistently appears as a focal point, why signals and objects seem to originate from that quadrant, the answer might be remarkably simple. It lies along one of the primary cosmic corridors, one of the grand arterial routes of the Milky Way. And if probes have been or are being dispatched, it's logical they would follow these established paths. We must not underestimate the profound implications of this possibility. If gravitational pathways exist and can be harnessed, then the galaxy is not an empty expanse but a connected system of interconnected hubs and nodes, akin to an ancient trade network. This suggests that our solar system might not be an isolated outpost, but a waypoint, a port of call for travelers riding waves far beyond our current grasp. The disquieting aspect is that we might have already encountered evidence of this without realizing it. The flight path of Atlas, the mysterious WOW signal, and even the outward trajectory of Voyager 2 all point towards Sagittarius. If this is mere coincidence, it is an extraordinary one. If it is by design, it implies we stand at the precipice of a cosmic chart we did not create, observing the boundaries of routes we have yet to understand. It suggests we are not the inaugural navigators of these celestial seas. This leads us to our concluding inquiry. If Voyager 2 is departing along one corridor and Atlas arrived via another, then somewhere in the vastness of space their paths may intersect. The notion is poetic, yet undeniably unsettling. What occurs when our message, a fragile spacecraft bearing a golden record of our civilization, encounters another message or another vessel dispatched long before our existence? This is the thought we must carry into the final segment of our journey. Part 15 concludes with the concept of the cosmic mirror. In October of 2025, Voyager 2 continues its outward voyage, a minute ember of human ambition venturing beyond the planetary sphere of influence. It is now approximately 150 astronomical units distant, more than 23 billion kilometers from home, advancing roughly 3.1 astronomical units further each year. Its heading is towards the constellation Sagittarius and Parvo, charting a solitary course below the ecliptic plane of our solar system. And within this fact lies a peculiar and haunting symmetry. For if 3 Atlas originated from Sagittarius, then Voyager 2 is now venturing towards that very same celestial vicinity. One emissary outbound, one emissary inbound, 2 narratives converging across millennia. Voyager 2 carries the golden record, a disc inscribed with the sounds and imagery of Earth. Music, greetings, scientific diagrams, a message in a bottle cast into the cosmic ocean. We dispatched it with hope, but without expectation. We understood it would take tens of thousands of years for it to approach another star. We did not anticipate a reply. Yet now, with the trajectory of Atlas suggesting a potential inbound messenger, it feels as though we are already participating in a protracted conversation that commenced before we were even aware of it. The WOW signal of 1977 was a singular event, a narrowband radio pulse that persisted for 72 seconds. No repetition, no explanation, yet it emanated from Sagittarius. In that same month, Voyager 2 departed Earth, and decades later, an object arrives from the same celestial region. Individually, each fact is intriguing. Collectively, they form a pattern too striking to disregard. One message outward, one message inward, one signal in between. Perhaps it is coincidence, or perhaps it is cosmic choreography on a temporal scale far too immense for us to comprehend. The mirror is not solely scientific, but also philosophical. We are so accustomed to perceiving ourselves as solitary beings, as isolated entities transmitting signals into a void. But what if we are already engaged in a dialogue, simply too impatient to perceive the complete exchange? Civilizations enduring for millions of years would not communicate in mere minutes or days. Their exchanges might unfold over epochs. A probe dispatched 1 million years ago could still be reaching its destination now. A response to our radio transmissions might not return for another 10,000 years. What feels like silence to us could be a conversation to them. There is a profound concept at play here. What if first contact is not the dramatic arrival of a starship, not an instantaneous signal decoded in real time, but rather a gradual exchange of artifacts? A probe here, a record there, objects passing in the night like messages tied to bottles, drifting on ocean currents. We may already be enmeshed within this process. But the narrative unfolds too slowly for our species, which measures history in centuries, not in cosmic scales. Voyager's golden record is a testament to our identity. It is optimistic, brimming with music and greetings. If Atlas is a message, it is silent, mute, or simply undeciphered. It carries no discernible record, no signals we can detect. Perhaps herein lies the divergence between us and them. We project ourselves into the void with symbols and songs. They communicate by orchestrating the movement of celestial bodies and cosmic dust across the stars, leaving enigmas that may require centuries to unravel. Which approach is more patient? Which is wiser? This is the cosmic mirror. Voyager 2 represents us, a species just beginning to converse with the galaxy. Atlas represents the other, an arrival that compels us to contemplate whether we are being observed or if we have stumbled upon the remnants of beings long departed. Together they remind us that we are not merely observers of the cosmos. We are participants, whether we choose to acknowledge it or not. We have stepped onto the stage, and the stage may already be occupied. The reflection deepens when you consider the narrative Voyager conveys. Its record proclaims us a species of music, mathematics, and culture. But what if the beings who encounter it have already witnessed our radio emissions, our nuclear detonations, our climate crisis? What story will they believe? What narrative will Atlas impart about us when the two messages, outbound and inbound, traverse the same galactic neighborhood? That is the question that should occupy our thoughts. Perhaps nothing will transpire. Perhaps Atlas is merely ice and dust, and Voyager will drift eternally alone. But the coincidences are too striking, the alignments too uncanny to dismiss entirely. And within those alignments lies a reminder that we are part of something grander. We are one node in a network we scarcely comprehend. We are a species dispatching and receiving messages without realizing we are already engaged in dialogue. The final contemplation is sobering. Atlas may not be definitive proof of extraterrestrial intelligence. It may not be a probe. It could be random, ancient, and devoid of significance. However, it has compelled us to re-examine ourselves, to recognize that when we dispatch probes, signals, and records outward, we are entering a conversation that may transcend the lifespan of our species. It may endure longer than Earth itself. Such is the magnitude of our endeavor. And thus, the concluding question persists. When our message and theirs converge, whether tomorrow or in 10,000 years, what account will they offer of us? Will they perceive a species that reached for the stars with curiosity and hope, or one that vanished before grasping the answers? The mirror has been raised, and we cannot look away.